Don't clip that. Hold on. And I realized by saying this, I inevitably probably caused Tyrion to clip it. Let me try again. Hold on. Okay, I got it. I got 14 loaded. So I think the issue was the lighter. Let's try this. I might need more fuel now, though. I'm like nervous though. Jeez. Oh. Vince, what was I doing, Vince? What was I doing? Literally, I was just like, Bits is right. I should brace the camera. Pow! Right into the camera. Ready? Oh, hey. What's the walk by? And I'm like, ready? Watch closely. Here we go. We'll do a couple runs, but 3, 2, 1. What'd you guys see? We should ask Melko what it was like back then. I think so. I think that would be a good thing to do. When he was a paper boy, like a little chemistry studying paper boy, what was it like? And he was out there like, X-ray, X-ray. Read all about it. I'm a nerd. I might need to use the blackboard here. Imagine contours of strength. I imagine contours of strength. These contours of strength? Last time, we taught, and I will do it last time this time, because last time, I didn't do it last time, and I had to do it last time. So this time, we'll do it last time. So when we make the variation, when we Taylor expend it, we'll have to do the whole, the function, I'm going to take the derivative, and everything. It's going to be really good. I'm glad you guys like it. Let's give a little cut into that sausage, too. Let's see how this looks. Let's see. Just beautiful inside of the sausage. Down a little bit. There we go. Nice, creamy goodness all over the place. I'm really, really excited for this. Oh, man.
This looks so good.
I'm glad you guys enjoyed this.
Welcome, baby.
Ooh, look at that. So one thing about this is, like, that was no alcohol, okay? I don't know if you guys could see that or not, but that was no alcohol. What that was is that was oil. Now, you can see it going off a little bit there again, too. Flame. Ah, man. Ouch. Running out of good quality rubber bands. Ouch.
Are you okay, Dad?
Yeah, I'm good, buddy. Thank you. Ouch. Seriously, stop. Holy smokes. Ah, thank you. 3/4 cannot be less than or equal to 1/2. That makes no sense. I hope you realize that this makes no sense. It don't make no sense. No sense. So what do? Well, we have done 2 different ways to show that if you talk about probabilities of spin up, spin down, if you're measuring a set of particles, they're not the same. If you talk about okay, so, ready? Here's the cup trick. I don't know if you guys can see the cup trick. Back in my day, we didn't have to do cup tricks as it spills all over me. Curse you, Twitch chat. Curse you, Twitch. Here we go. Working Tesla coil. Tell me you guys can see that. Tell me you guys
I totally
can see
see it lighting up.
that. No way, really? Oh, that's amazing. All right, we're gonna watch it. Hey, shush, 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 shush. So if you don't know the double slit experiment, let me tell you what the double slit experiment is, okay? Let's go to the board for this. Oh yeah, let's go to the board. Here we go. 3, 2, 1. Jeez. We're good.
Dance monkey.
Haha. Okay. Good? Hello. Hello. Good to see everyone. Hi, Sarah. Hi, Kerr. Kerr, I see your questions. We'll get to them in a second. Bachman, good to see you. Good to see you. Cyber, good to see you. Tensor, what are we blowing up today? Nothing. Nothing today. Not blowing anything up. It's no, we're gonna actually take a break from building today. I gotta get I gotta get freshies, fresh batteries for this because they are they're gonna die on me here in a second. So we might as well do it now. Admiral. Last week was so fun. I really enjoyed last week. As soon as I say that, this dies. So I can't hear anything right now, so hold on. Last week was really fun. And I'll kind of give everybody a little up-to-date on what's going on and why we're not building today in just a second. How do I live without you? I have to know. Oh, there we go. So we have sound again. Flat Earth Intellectual. Good to see you. Good to see you. Let's see, who else is here that I'm missing? Strawberry Jesus. Good to see ya. Tyrion. Afternoon, you slacker. I hate everyone today. From Tyrion. Good to see you, Tyrion. Good to see you. All right. We have a bunch of really good questions. So my moderator, bless her heart, Jax, has pitched me a softball and asked me a lot of really, really good questions, which I can't wait to start getting into. Really, really good questions. So we're going to get into them. Kurus is asking a bunch of good questions, too. I did say ask me literally anything. And these are some really good questions. I didn't say I would answer everything, but you can feel free to ask me anything. So I will get this out of the way straight out of the gate so that everybody knows we are not doing a building stream today. We are taking a break from the usual content. I've always thought it would be a lot of fun to do the like some sort of like ask me anything type of stream where that's the content. Am I too loud? Am I too soft? I'm back to lapel for this week since I'm not moving around a lot. K-Girl91, how are you? Good to see you. Good to see you, good to see you. So usual content, if you are new, I usually like to do lessons. We do physics, rigorous stuff, mathematics on the board. On Sundays, we usually build things, demonstrations, physics demonstrations, and do stuff like that. But today's a little bit different. I'm grabbing all these questions and moving them over in the queue. If any of my moderators are on queue, I recommend you can go ahead and move over anything, and I'll just delete it if I don't want to answer it.
Volume is good.
Volume is
You are
good.
yet too soft.
I'm too soft? I'm confused. Should I go harder? Try adding more bass? Maybe I could, I don't know, I'm almost peaking. I am peaking a couple times. I don't know if I can do too much. Okay, so, like I said, if it just let me know what it's a joke. I get it. Soft is in like chemistry. That's what you meant. I get it. Hi Ella. Hi. Oh, wait, so K-Girl says, physics is the one class I managed to avoid in undergrad, and I'm happy to say I don't need it for my master's program as well. Bad at math. It's a bummer. It's a bummer. Math is one of those things where I think you have to really either want to learn at a later age, or you have to be learning steadily throughout the entire school process, starting at a very young age. Math right now is a mess in like elementary school, in my opinion. We'll have to see. I'll have to see how that goes with math. My kids are all in elementary school. Okay, so my two oldest ones are in elementary school. My third is going to kindergarten next year. She's in preschool right now, and I think she's doing good math right now. I think any math at the preschool level is good math. She is doing math too. But yeah, I'm surprised by that. But I think any math at the preschool level is good. But the kindergarten and stuff, it's a little bit strange to me, but it's not necessarily bad. I'm just kind of curious to see how it goes with the kids as they grow up. Math's at a weird state. Hi, Cosmolano. Good to see you. Good to see you. Okay, so yes, like I said, we're taking a break. Boring math professor. BMP, good to see ya. Who could do it first? BMP. Me, got it. Go give BMP a follow. He's actually quite talented at math and at sporting fancy wigs. Haha, Tyrion. Actually. So you guys, I mean, let me just say firstly, the reason we're not having stream today is simply just because I've had a rough couple days, just mentally. That's all. It's been rough, and I wanted to be upfront with you guys. I thought about trying to force it and do the build anyways, because even for someone who studies physics and math every single day, it's not easy, and there's a lot of times where things happen, good things happen. Bad things happen, good things happen, and it just doesn't matter what happens, but you just start to get down on yourself. And I'm not gonna try to get like really. Like I said, I don't want to be. What's the word? I feel good. Like, don't get me wrong. Like, I'm in a good spot, and I think that I'm in a good spot because I made a good decision, which was this morning I woke up and I was researching for the build today, and I was very overwhelmed and very anxious and feeling really, really just down on myself. And I said, it would be bad content for you guys as viewers, and it would be bad for me mentally. So I thought to myself, let's just not force it. And there's a couple things I'm going to talk about. I have some notes to talk about as well. And it was like and it's some stuff that's been going on. Also, I want to talk about the build, because I do have a build. What was the previous week? Last week we built a cloud chamber and looked at particles. And I'm glad you guys are so understanding. It's fantastic that you guys are. I mean, you guys are so supportive. And that was one of the biggest things, is because I was sitting there thinking, I want to be with my community. Like, I want to hang out with my community. How do I hang out with my community and also not let them down? And so far, I think that we've had a great time with answering questions and just talking. And if we end up finishing it earlier, or, it doesn't go the full 3 hours, and so be it. Judging by this list of questions I have so far, I have 15 questions in the queue right now. So I think we're going to have some questions for a while. I think that's awesome. Cool t-shirt, by the way. Oh, thank you. And then I have these so I still have 15 questions. But yeah, if you are new and you would like to ask me a question, what you can do is put !ask space and then your question, and it will go to a separate monitor I have here where I can keep track of it. And I have at least one mod, if not multiple mods, on the queue as well to help me shift problems around. If you ask 2 questions in a row, it won't pick up the second question until I move it manually. So that's why I have mods helping me. It's not the best setup, but it's really good for this because I lose a lot of questions in chat. But K-Girl says, I remember my micro econ professor telling me during a lesson I was lost on K-Girl, it's basic introductory college algebra, and I said, you don't get it. I took that class 4 times before I passed it. I hear that. I hear that. I actually took a class 3 times before I passed it. Might have been 4. I kind of lost track. I might have taken the class 4 times and passed it the 4th, but I definitely took it at least 3, if not more. You missed the last quantum computing stream. It was good. The video's up on YouTube if you want to get caught up a little bit. It was circuits and quantum circuits and quantum teleportation. Both very exciting things in my opinion. Where you can actually take an entangled state and move it from one quantum computer to the next quantum computer while also, while preserving the quantumness of it. Failed my first exam yesterday. Yeah, that's rough. I mean, it's rough. I mean, that's rough. And like, there's always a chance to come back. And I'm proof of coming back. I am proof of coming back. It's hard. It's hard to fail. And like, I remember the first few times I failed, it was bad. You want to talk about spiral. I was a lot younger though. Luckily the second time I went back to school, it was less, I was able, I didn't do as bad, but it was a mood change and a mindset change as well. Sarah says, you can always take time for you. I'm sure at this group you could just show up, no plans, and keep you busy for hours just chatting. I love that, though. I love that. That's one of the reasons I wanted to, because you guys are hugely supportive. Hi, Sir Hellcat. Good to see you. Good to see you. Very flexible group. I love it. I love it. Some of you run out of chances and patience. I think you might be surprised, but I can't help about the patience thing. But the chances thing, almost always there's someone in academia, and I know Tyrion is partially joking, but I know that there's somewhere in academia where people are willing to give you more chances for sure. Yeah, and it might be difficult to find. It will be difficult to find. I have my story. I don't know if Jax is here. I think it's Eric's story. Did I get it? I got it. So that's my whole story. If anybody is new to the channel, doesn't really know me, that's a little bit of a longer story. Mandry Jane! Good to see you. Good to see you. Boring Math Professor says, I failed a class once. Gave them all F's. Oh no. Oh boy, that's funny. Okay. But yeah, so we are going to do something a little bit different today. I will talk about some of my funk later. And I will talk about the building stream a little bit later as well. And then some other just key notes I have. But in the meantime, let's go through some of these questions. I'm going to hit some of the easier ones to start with while everybody is meandering in. Jax, my moderator, like I said, asked some fantastic questions, which I'm going to hit up in a second. But let's hit some of the easier ones. Kerwurst has some good questions. What is my favorite food? What timing? And see, I just like that there are other people that just want to hang out and talk about physics. It's awesome. I love that too. If you're not in our Discord is almost 250 people strong, and it's a great place to just talk and to ask questions and to learn about physics together. If you're stuck on something, if you're looking for paper ideas, if you're looking for research ideas, great resource. Not necessarily me, but someone in there will be a good resource. Sometimes it's me, but sometimes it's not me. And that's a wonderful community where you can get very active in asking questions and hanging out, contributing papers. Maybe you can answer questions. Looks around for Justin. Let me answer a couple of these questions to get started, okay? Kerwurst says, what is my favorite food? That's a hard one. I don't know. I really like brine. If I had to give like one thing that I really like brine. So that's pickled stuff, really. Pickles, obviously, are one of my favorite, but green olives as well. Green olives are one of my favorite things to just, I mean, it's weird. Do I like capsalon as a meal? Because it's a brilliant food. Let me look it up. I don't know if I've ever had it, actually, and if I have, did I say it right? Capsalon? It's a fast food dish created in 2000 by the Dutch Ronnie. Let's see.
Good morning, son.
French fries placed in a disposable amount of okay.
To the heart upon your brightness.
Interesting. No, I don't know if I've ever had that. Let me keep my eye on the queue a little bit. I don't want to lose stuff here. Okay. So yeah, I think things that are on brine. Bitter umami flavors. Yeah, I really do. And in fact, like, so Kerber asked another question, but like, I really like really strong dark flavors. So like, I like a lot of IPA. I like IPAs. I like dark black coffee. I like Sauvignon wines, really dark red wines with a lot of tannins. What's my favorite movie? I don't really have a favorite movie. I am Toto. Hi, buddy. Good to see you. Good to see you. Do dinosaurs know physics? I don't know. They probably if they did, they didn't know it as well as we do. Rooster. Good to see you. Good to see you. Darth Flavor, Lord of the Brine. Very nice. I don't know if I have a favorite movie. That's a good question. I really like Lord of the Rings trilogy, and I really like the Harry Potter's movies. I don't know if I have those probably. I really enjoy those movies. I can watch those movies if they're on, but I think that's I can watch it. I do love some biopics. The one I saw very recently was Hidden Figures. That one was absolutely amazing, stunning film. I really like The Man Who Knew Infinity about Ramanujan. I really like the one with Turing. The something game. It's the Enigma. No, it's not. The Enigma's machine. What's it called? The Imitation Game. Imitation Game? Something like that? Something like that. Imitation Game. Yeah. Really good movie. Okay, what's next? He also asked how long he would have to subscribe to get a picture of me naked. And I would imagine it'd be a few decades, probably like 10 decades or so. So yeah, so if you subscribe for about 10 decades, then hit me up and I'll send you a picture of me naked. So let's see here. What is my craziest experience when I was drunk? I think that one's just one for my wife and I. I was married. I don't get drunk, really. And it's not because I drink a lot. Because I don't drink a lot. It's...
Dear Anubis, a naked picture will make you go blind.
Especially when I'm 132. But if you still want it after 10 decades, hit me up and we'll see what happens. My wife reminded me I really like The Muppet Christmas Carol. That's my favorite Christmas movie by far. I really like The Muppet Christmas Carol. That's my favorite Christmas movie. I like how all of a sudden I get a bunch of holding things because I was talking about the naked pictures. I now really look forward to receiving a naked picture of Amanda's mid-40s. I said decades. So in 10 decades. So when I'm 132, then I will start sending out pictures. The Muppets are the best. And it was really funny because if you go on Twitter, I am on Twitter, and someone who I like to interact with is Dylan Berger. I was on his podcast once a long time ago. Or I guess it wasn't that long ago. It was in March or April or something, maybe May. And he said he had this one thing on his alt that was like fill in. It's like intro to and then let auto fill in the rest of the words to your textbook, right? And you're starting the clock. Start the clock. Noah Royce, good to see you. Take a new now and save it for 10 decades.
I mean, I guess at that point, what's it matter, right? I'll be 100. I'll be like, this was me. Anyways, so my autofill story is not as funny as what Noah Roy said. But anyways, I did the autofill thing, and you just do it on your phone, right? And it said introduction to the variety of a Muppet. And it was just like, oh man. So apparently I'm going to write a book about all the different Muppets and, the different variations of Muppet that was available in the Muppets. Fantastic show. What happened to Dylan? He was doing a lot of content creation. I think he's just waiting until he gets a little farther in his PhD or after his PhD. He made a post about it not long ago, saying that he just wanted to just wanted to put it off a little bit and focus on his PhD, which I totally get and respect. And when he does do it, pay attention because he puts out good content. He really does. I told Dylan we should do a podcast over a year ago, and then he started one on his own. Never had me on, ruined our friendship. Oh, that's too bad. I mean, people do different things at different times. So, yeah, that's a bit of a bummer, though. Muppets are dark matter particles. It's just, can you imagine? If you get a naked picture now, you can title it what? Oh, rude. Okay, so TensorCat says, what's my favorite... Oh, wait, I skipped a couple. Hold on. How did I skip a couple? Okay, so my crazy experience when I'm drunk. Yes, I don't drink a lot. I've only gotten drunk maybe less than a handful of times for sure. And all within the comfort of my own home. I don't mess with that at all. I'm actually not a fan of being drunk or whatever. Just like I don't smoke because I'm not a fan of being high. I don't like that feeling. But I did, there was one time that was, let's just say it was, that's a story for my wife and I. It was, it's funny now. It might not have been funny at the time. We have a new cooking, thank you for reminding me, we do have a new cooking stream. And a new cooking stream goal. You don't like the high feeling, you said. It's true, I don't. Hi, BPS. Good to see you. Good to see you. Yeah, I really don't like it. So it's only been like a handful of times that I've actually been drunk. And it's really not. And it's always been, like I said, from the safety of my own home. But, yeah. Anyways. So that's that story. We won't go into it. Let's see. Tyrion said, why do you bring the worst in me? It's easy, I guess. It's easy. That's pretty easy. So yeah, so we have a new cooking stream challenge. Like I said, I owed you guys 40,000 points. So when I changed it, apparently I had to refund all of your points. So everything that you guys put into the last cooking stream got refunded, and then I still had to go down to the 93,000 because I owed it to you. So we're going to end up finishing this week probably. Ooh, that's a good question, Jane. That's a good question. I love my wife so much. Okay, let's see here. And I will definitely talk about her all the time. Since we were talking about quantum computers last time, I heard that optical computers were a thing and the benefits from them. I also heard that they were a good potential platform for building quantum computer out of. Why is that? Well, because you can interact things with photons in very specific ways. Let me kind of give you like, and this is just what I imagine from hearing that for the first time, is what is the Stern-Gerlach machine, right? A Stern-Gerlach machine is one of the things that we've been using often for discussing like a quantum computer, right? Because you can take and put a computer into you can put a particle into a Stern-Gerlach oven and superimpose it into a different state of up and down, right? And then you go through and you measure it, and what's doing that measuring? Well, it's a magnetic field, right? So at least part of that is being carried out with a photon, right? Even if it's a magnetic photon. And there's a bunch of different things that you can do with photons in that, guys. Like, I even said that the wires last time for a quantum computer were, one of them can be done with photons, as like transferring information from one to the next. As far as how to do it practically, I don't know. Soiku, good to see you. Good to see you. As far as how to do it practically, I don't 100% know. But they do show up all the time, and they're very, very helpful for quantum computing. I do know that. And then the basic example I can give you is something along those lines. I know a lot of things that have to do with magnets, but I don't know a lot of things that have to do with optical stuff, unless you can do stuff with optics and magnets together, which I'm sure you can, because they're just, if it's just, well, yeah, I'm not 100% sure. Maybe Admiral might know more about the practical applications of that. And honestly, that's wild. Yeah, cool. I don't know enough about optical computing. I've heard of it, but I don't really know what an actual optical computer does, other than flipping bits with light. But I don't know how you control it or anything like that. But good question, Cyber. Maybe there might be someone who does know, especially on Discord. Okay, let's see. TensorCat says, "What's my favorite meal?" My favorite meal. I actually don't really know if I have one. I'll tell you a guilty pleasure I have, okay? We also have biological computing. Cinnamon, I didn't know that. That's pretty gnarly. Biological computing? Interesting. Nonlinear optics use polarization as qubits. Oh, so it's a form of quantum computing. I thought they had optical computing in classical computers. Well, I mean, I guess you can just use, I guess it's just measurement gates all the way down. But interesting. But there you go, Cyber. But I don't really know. So I'll tell you my guilty pleasure. My guilty pleasure is, unfortunately, Stouffer's lasagna. And I promise you, it's a guilty pleasure. Now I have to, because I'm off of beef, I have to eat the veggie one, but it's still really, really, really good. So it's my guilty pleasure. I mean, it's super not healthy for you at all in any vague sense of the word, other than it has calories. But it doesn't really have any. I don't know how many of the good things it has. Yes, Stouffer's. So that's my guilty pleasure. And the meal that I'll have, I don't eat it often, maybe once every 2 months, maybe once every month if I'm feeling extra spicy. Just because I'm aware of how not healthy it is for you, but it is really good. What else do we have here? What's my favorite? Oh, so Kurtwurst asks, what's my favorite song/band? Okay, I don't have a favorite. I would have to say probably my all-time going back to is Coheed and Cambria. Really, really, really good band. If you don't know Coheed and Cambria, it's like progressive rock with some like the hair of metal thrown in sometimes, but they're all over the place. And I'm really digging bands that are all over the place like that as well. I like the heavier Coheed and Cambria stuff more, I think, but the soft stuff is really good as well. Their one album that he wrote that's not concept, the one about color. An island I think the first song on it was Island or something. There you go. If anyone has any good resources about optical computing, they should put it in the Discord. Noah Royce said he would like to read some, so there you go. If anybody does have any good, and maybe I can even look into that a little bit too. My advisor might know a bit about that, actually. Optical computing. Okay. And then let's see. So that was that. Oh, but my go-to right now for working and stuff is Polyphia, which I think Tim Henson, right? I think he's the lead guitar, and they're an instrumental band. So he's phenomenal, and I think he streams on Twitch actually. I'm not 100% sure about that because I don't actually follow him on Twitch because I just listen to their YouTube songs all the time. But I have seen him live streaming. I've seen VODs of him live streaming on YouTube, so I just extrapolate that to Twitch, but someone should check that out. But Polyphia, great instrumental band. Really, really, really good. Yeah. And I love the different sounds. And then I've been listening a lot to Periphery lately. Their new album is all over the place, and I love it. They have some of the heaviest Periphery songs on the new album, and they also have like the lightest Periphery possible, which is still not anywhere near as light as like Coheed and Cambria, but it's still really, really good. And the whole album is fantastic. Go is excellent by them. I thought you said Nickelback was your favorite band. Okay, Tyrion. That's what I ask. Am I okay, bro? I am okay. I think I made good decisions today. I think that's why I'm okay. I think if I really tried to force a stream, I would have had a really, really miserable day, and it would have amplified all of the problems. But the build today, if you guys would like to know, the build today, and subsequently we'll start it next week, is we are on to the Van de Graaff machine. I've told you many times I want to make a Van de Graaff machine, but I have never committed to making one. We are going to make we are going to make a Van de Graaff machine starting next Sunday. However, there's going to be one key difference to our Van de Graaff machine and other Van de Graaff machines, is that if you don't know what a Van de Graaff machine is, it's basically using friction by stripping electrons off of objects, electrons and positrons, separating the charges from two different objects, and then collecting them on a collector, usually like a large metal sphere, and then using that to either power something or just make really big sparks. It's hair-raising, as Adam says, yes. So no one was seriously injured. It might be injuring. We'll have to see. Here's the thing. If anything, it's going to help me get rid of some of that heavy water, because I'm going to be making a hand-powered Van de Graaff. So I'm going to be taking apart a bicycle and using the pedals as a hand crank to make the Van de Graaff to run the belt that will be doing the stripping of the charges. So, let's see. But that's what we're going to be doing. That's the next build. It's going to be pretty straightforward, bicycle pedals. I might also get a small battery power motor just to see. I also have some drill motors, and I thought maybe today we would just rip apart a drill, because I have a dead drill. If you guys remember from one of the videos earlier, one of the streams earlier in the year, I killed one of my drills on accident. I don't know why, it just stopped working. I didn't do anything. Unlike the voltmeters, it's just basic stuff, PVC pipe, pantyhose, and metal spheres, and stuff like that. So, pretty basic stuff, and yeah, that's the next project, a hand-powered Van de Graaff generator. And we're going to talk about the science of it, and we're going to build it, and it's going to be a lot of fun. But I am okay, so thank you for asking. You guys are so supportive. It's amazing. Kurtwurst, do you think light beer should be called beer? As a Bavarian, I think it's brutally insulting for real beers. I do. I'm a little more liberal with what you call things, but you should call it a light beer, so that if someone who drinks real beer, they don't get confused, right, with it. You don't want to say that. Make sure that you know that it's a light beer. Like, you should have if you go to a restaurant and you have a menu, it's like the dwarf planet thing. Is Pluto a planet? Sure. What kind of planet? A dwarf planet, right? And there's a ton of them, so he's not special, okay? There's a lot of dwarf planets, other than the Heart. The Heart is pretty special. But other than the Heart, Pluto's just, they are what they are, it's just a planet. And it's just a dwarf planet. And that's what you should do. And on the menu, if you go to a restaurant, you have a menu, right? You should have, like, beer, and then you should have wine, and then you should have whatever, wine coolers, and then you should have light beer. You don't like American beers? You gotta try. There's a lot of beer. My go-to cheap, if I'm gonna drink something cheap, it might be Yingling. But like I said, I don't drink a lot. Or often, really. Well, I kind of drink, maybe. But I don't drink a lot. I drink very minimally. And when I was working in the restaurant, I had to kind of force myself to get used to IPAs. Because IPAs, I corrected it. But IPAs are, you have to get used to them. And when I was in a restaurant, Yingling Black and Tan and Porter's really good. Yeah, so my wife and I, we have a drink pretty much every single day, if not every day. And she likes stouts and will drink porters, and she likes the Yingling porter, and she likes other things with a lot more flavor more. Hey, Science Streams. But when I was in the restaurant, I was forced to try things. Like you have to try food, always trying things, always eating. And even if it's just small amounts at a time. And it was, yeah, and so after a while of tasting IPAs, eventually they just started to taste really good. And then it was like I could, my wife wanted to make sure that you guys know that Guinness and Yingling are very weak. Guinness is really weak. American Guinness is very weak. American Guinness is really, really, really weak. Yeah, not good. So, let's get on from that question. That's a good question. But yeah, I like IPAs, probably my most favorite thing is IPAs. And I had to get used to them. And then the different kinds are really good. If I had to pick a favorite one, I would probably say Dogfish Head 90. Really, really good, but expensive, so I don't drink it very often. Let's see here. Tyrion says, my bank won't give me a refund. So it's all good this month. Good, Tyrion. Sir Hellcat said, I've been studying Dirac's quantum relativistic theory, and I have had a hard time understanding spinors. Could you give me a viewpoint of what spinors are? Yeah, absolutely. So spinors exist in a wave function. Let's go to the board real quick. Spinors exist in a particle's, the function that describes a particle. Okay. Now, these functions that we use to describe particles, okay, they have to be very inclusive. They have to include everything. Okay. I'm gonna do this off the top of my head. I hope it's correct. Maybe someone's in chat can help me. But if you have a Dirac field, right, then you're gonna have some, I don't know what this is, like d, I don't know, p to the fourth over 2 pi to the third or something like that. I don't remember the outside. This part doesn't really matter too much. What matters is what's on the inside. And on the inside, you're gonna end up with a u, p, s, and then an a, I think it's usually dagger first, right? An a, p, or something like that. Maybe I should just look it up instead of trying to wing it. We're gonna go with Shred Nikki. Shred Nikki, I can usually find things pretty quickly. So let's look up, let's see, Dirac, or fermion path integral. So if I have a mod who can watch the queue for me for a second, that'd be helpful. The path integral for fermion fields is 43, page 271. That's my best bet for finding this equation. And can I find a equation of a particle? Maybe it'll be before then even? Let's see. Yep, there we go. Okay, let me write out the whole thing. If you have Shred Nikki, it's on page 267. So here's the full fermion, or Dirac field. So you sum over all of the spins, right? And again, we want to make sure that we're inclusive. Plus or minus is really the only spins we have. And they just say dp with a swirl. I'm sure that's, or a tilde. I'm sure that has, you know, a good definition. So then we have one annihilation operator and a spinner, and then a phase, and then another creation operator. And then these things are different for antiparticle particle, obviously, because it matters for a fermion. The SP e to the I p x. Okay, so the goal is to understand what this and what this are. Those are two different spinners for two different things, okay? One of them, and this is all for the particle. There's another term of this where it's, you know, the Hermitian conjugate or whatever. And these two spinners have to include all of the information about spin, okay? So that has to do, with basically a vector representation of all of the information that a fermion, a Dirac fermion, could have for spin. So all of the chirality considerations, what direction it's spinning, what direction it's traveling, what direction it's spinning, what direction it's traveling, and whether or not it's a particle or an antiparticle. Okay? And this is usually given in Dirac spinners by 4 components and in Weyl spinners by 2 components. A 2 spinner is an element of c squared, a vector with a complex number of components, an electron is a spinner, a positron is a complex conjugate. Dirac spinner is a 4 component. Yeah, so the 2 component is what's called Weyl spinners, and the 4 component is a Dirac spinner. Yeah? Yeah, and then what Cosmolano says is like the whole inclusive thing of both of them. So that's what a spinner is. So Hellcat, is that okay? I mean, you can do more stuff with it, but it's like, I don't want to bog you down with any other things besides like identities, because then you can go into like a whole bunch of identities about like what a spinner is or does in terms of a particle, and then how you actually like split it into one or two. I'm sorry, a 2 component spinner or a 4 component spinner. Those are different things as well. Like how to split it into those two different things is a whole nother lesson, I guess. But that's what a spinner is. It's a vector that describes the possible spin of a particle. And like the wave equation that is right there, the field equation, of a Dirac field, that has to include all possible information. So a spinner is really just every bit of information that a Dirac could be, and then usually it just collapses into one of those things if you consider one single particle. Okay, good question, good question. Cosmolano said, I read that algebraic QFT is needed for doing QFT in curved spacetime because the algebraic formulation gives us a way to compare states in unitary equivalent Hilbert spaces. Why can't we just talk about quantum gravity as stemming from this? It cut off the end of that, Cosmolano, probably just because of the space that it had. But do we need algebraic QFT for QFT for curved spacetime? I don't know. There is, I don't know. That is definitely a Justin question or someone else who has more information or who's done more about curved spacetime and QFT. You would need to talk to. I've done nothing combining anything but flat spacetime and QFT, and for my like minimal thing, it sounds like it would just be like for my minimal knowledge, it just sounds like you can just do a different metric, but it's probably really wrong. Do we need an object like the metric or convention to exist in a Hilbert space? Yes, we do. We do need a metric to exist in a Hilbert space. If your next question is why, again, I don't know. I have a very practical use of QFT as far as like being able to work through the formulation step by step. But as far as like bringing up the formulation of it and why we need a metric to get through the path integral, I'm not sure. That's a good question, but unfortunately, maybe just your Hilbert space comes from an inner product for free, but that's not the metric on space-time. Maybe I'm a bit confused about where does the metric come from for space-time? Like, why do we do everything with a flat space metric? Or am I thinking about that wrong? Because I've always just assumed that when you do not path integral, let's be more clear. When you're just doing an integral with propagators in space, you want to use a flat space-time. In like when you're learning QFT. Like my QFT knowledge is very, very much at like a small. I'm getting some coffee. I don't know if anybody wants to have coffee. Let's have a cup of coffee together. But yeah, I'm not 100% sure where that metric comes from now that you asked that question. I just assumed it had something to do. I just assumed it had a lot to do with the doing the metric associated with doing the propagators. Like the energy terms and everything like that comes very naturally from that way of thinking, in my opinion. But anyways, coffee gang, nice. All right, let's go on to the next question. Those are good questions, but unfortunately, it's not my strong suit, unfortunately. Do you believe in the olive theory? Does it apply to you and your wife? I don't know the olive theory. Olive Garden. What is the Olive Theory? The show the Olive Theory states successful relationship balance is everything. It couple. The Olive Theory is what defines them as a great couple. I don't know. I try to do better than that. I try to put all of her needs before mine, and I think she does the same. And obviously we don't do it perfectly, but I think the goal in our relationship is to put the other person fully above yourself. And if they do the same, then usually things get done properly. And if they don't, then there sometimes gets tension between us. But as far as if you want to talk about who does the dishes or something like that, it's we both do it as much until we're done, and we work together until it's done. So in that sense, yes, I guess we just all the work and appointments and everything like that, we just work together. But as far as it goes to what's my mentality for it, it's if I can get more stuff done than her, then that's a good thing for me, right? Because I'm accomplishing my goal of trying to do more for her so that she has an easier time. And she does the same, and I know she does that, and that's why it works. But if at one point, if and like I said, it's not perfect. Sometimes I'm a bit more selfish, and I'm sure she might say the same thing. And it is what it is. I mean, that's part of being human, though. Wait, this doesn't close? I would like coffee. Can you close, please? Thank you. Okay, I guess you're just not going to close. I hope that doesn't interfere with coffees. See that? I don't know. The Olive Garden theory. That's what I always thought of. But good question. I've never heard of that before. But interesting. I see a strawberry juice. I see your question right now, so let me grab that. Are there any sensible theories of quantum gravity? Absolutely. I would say all of them are sensible. None of them are finished or done. I don't think theories are going to last very long if they're not sensible. I think string theory is sensible, and I think loop quantum gravity is sensible. I would also say there's theories that aren't sensible. But I couldn't really speak to them, and I'm trying to grab your questions too, but you're like, Slor, thank you for the follow. Welcome to the channel. If you have any questions about anything, physics or non, just ask away. Exclamation mark, ask, space, and then your question. And yeah, but they're sensible, but I don't know about whether or not I would say. And if you just mean sensible to research, I mean check into them and see which ones you think are interesting. Hey, Haney. Good to see you. Good to see you. But yeah, ask. I would say do a little research on each topic and then find out which one you like and then go with that one. Research is all about following your gut, which we're going to talk a little bit about, definitely. Jane the Message says, are you familiar with Kenneth Laws? I started appreciating physics because of his work on the field of physics of ballet. He wrote a very cool book on the subject. Do you ever learn about applied physics for sportsmanship? I am not familiar with Kenneth Laws. I've heard of them in some context. I think from the Star Talk Radio, they do sports stuff. So I'm pretty sure I've heard of Kenneth Laws from that. But I'm not sure. But I don't really know of them or remember them at all, really. Interesting that he wrote a book on the physics of ballet, because ballet is one of those things where you have to have a really good control over your center of mass. And that's such a cool thing. I didn't even think about that. But my immediate thought about physics and ballet is center of the mass is everything, right? Moving around, doing stuff spinning up on your toes, because that can be brutal to your toes if you're not balanced properly. All sorts of stuff really makes me kind of think about that. Yeah, very interesting. And I imagine he goes into more stuff centrifugal force. Where my centrifugal gang at, right? And some other cool things. I don't know. Interesting. Very, very cool. But no, I'm not familiar with that. And did I ever learn about applied physics for sportsmanship? I did not. But I do know that that's a field. All the training in center of mass, really? Yes, cool. That's definitely cool. Yeah, I'm not too familiar with the sports stuff, with sports ball. I did play soccer, through most of high school and college. but I don't know much about the physics of it. No. But yeah, Star Talk Radio, if you're interested in learning about that stuff kind of like surface level, Star Talk Radio does do a lot of that. He has a lot of sports athletes on and interviews them, talks about sports, and does stuff like that. There are some moves in ballet where you have to be off-center to make it work, but then the motion carries you forward. You establish center. Ah, very good. So again, yeah, using conservation of momentum to get yourself rolling. Let me see. Have I checked any extensions of Bohmian mechanics to deal with relativity? I have not. So I'm under the impression that Bohmian mechanics and Admiral, I know you've done a little research. Maybe somebody else has done a little more research. Is Bohmian mechanics a field of quantum physics that uses gravity in a measurement? Maybe somebody can answer that. But I know that there's a group of people who are pushing that gravity is the mechanism for measurement. And Bohmian mechanics, I feel like it had something to do with it, but maybe, when you say played soccer, do you mean played soccer around you? No, I was a starter for most of it as a goalkeeper, and I had a lot of shutouts and a lot of 15-plus save games that were shutouts, and I had like one game that was like a 30-save game or something like that. I won all conference my first year at community college. So I was good as a goalkeeper. I made the news. I made the news one time. So I was quite talented as a goalkeeper in soccer, Tyrion, I'll have you know. They called me Spider-Man, the newscaster. The big soccer teams in UK have been hiring physicists to do their modeling. No way, Rooster. No way. I read roster. Thinking about soccer now. That's amazing. I would be terrible at it because I don't keep up with soccer and or football. If you really want some fun to do with physics of the pole vaulting pole, building stream, anyone? Build a usable pole vaulting pole? Interesting. Let's see. I'm gonna have to hit the gym before modeling. I'm gonna have to hit the gym before anything. Can you tell us some of the stories of your wife and yourself? Sure. So this also, Jane asked, how did you and your wife meet? So I'll cover both of those. My wife and I met at a summer camp, actually. I said a really funny story last time. I think it's somewhere in the clips or something, which I always enjoyed that story. But maybe it's even in YouTube. I don't remember where it is. But no, the real story is my wife and I met at a summer camp when we were 15. I think we were 15 when we met. And we started dating when we were 16. And we've been together ever since. We had one time where we were like, I think we were 16. No, must have been 17 when we started dating. Because 16 we started dating once, and then we realized we didn't really know each other. And she lived in New Jersey and I lived in New York, so we didn't really know each other too well. So we took a break, we'll call it, and then got back together as soon as we were back in person with each other. And after we spent the year communicating, because we emailed and texted and did all that stuff together. Well, I don't think we texted because texting wasn't a thing back then. But yeah, I think. You can tell when I'm getting like nervous because this makes me fun, or this makes me reminisce fun things. But yeah, we just emailed stuff and friended each other on MySpace. We wrote Zanga blogs, and it would be one of those things where you would read the Zanga blog and you would wonder if it's about you. Can anybody relate with Zanga blogging and like wondering if your crush's Zanga blog was about you? But yeah, we sent some emails. That was fun. And then, so here's a story. I'm gonna tell the guitar story. I don't know if this is acceptable or not. But my wife and I both so we were both dorks. And see, you realize that when I was that age, there was no texting. Like the rich kid had a cell phone. That was all. Just the rich kid. No one else. Hey Templar, I'm feeling good. I felt good because I made some good decisions, like I was telling chat a little earlier, and I feel good. If I tried to do a building stream today, I don't think I would have felt good, but I feel good now. You guys are amazingly supportive. Let me tell the guitar story. So my wife and I started dating when we were 16, I think. I'm trying to remember the actual year. It's too long ago. It's 2004. In 2005, I think we got together permanently, which would make us 6 years? Right? Somewhere like that. The years are slipping us. We got married in 2010, and I think we were together for 6 years. So it must have been, I can't remember if it was 2005 or 2004 when we first started dating. Anyways, so my wife, maybe she'll remind me. My wife and I, we've been together for 16 years, pretty much. And we both were into emo bands and like music, right? And it's good to see you too. If I didn't say that, it's good to see you. So I knew that she liked guys who played guitar. So in November, when we had the discussion, or December, when we had the discussion, December 15th, we had the discussion about not being official, but instead just being friends, because we were young. Of course, me, being a 16-year-old who was just like devastated by, this girl. No, I wasn't devastated. However, I did know that I wanted to be with her. I did know that. So I was not in an emo band, or an Elmo band. Although rocking Elmo is pretty cool, but I was not with. No, we were not in a band. Mandry, gifted sub to Templar. Thank you so much, Mandry. Thank you. Let's have a coffee. So I did know that I wanted to be with my wife, but I didn't really, I was 16. How's anyone to know these things? But I was just stubborn, I guess, and determined. And I'm really happy I was. And I decided the next week, after the 15th, that I would learn the guitar and woo her back. I kid you not. When we went back to the summer camp, the goal was for me to play the guitar and woo my wife back. And Twitch chat, I am pleased to inform you that it worked. I did, in fact, learn to play the guitar and woo my wife back. Woo I did. I knew I would hate you when I was 16. So woo-hoo for me. But yeah, that was definitely one of the decisions I made. Yeah, we ended up seeing each other again in June, and we just, for the next couple of months, we just bonded like as friends, but in person this time, because we were still writing emails, right, back and forth, and then in August we started dating. And then we never broke up after that. We stayed dating ever since then. So, and we were 17 going into our senior year of high school. It's all coming back now. We were going into our senior year of high school. So there you go. And we went our separate ways in the fall, but still stayed dating. And then I ended up getting a cell phone as a senior and could text her. So that was fun. And then when we went to college, we kind of went separate ways. I stayed in New York while she was in New Jersey. No, she went to the other side. She went 3 hours to the other side. And then I went to New Jersey, and she went home to New Jersey, so we were an hour and a half away, and then we got married. And then it was good. Was it a rotary cell phone? No. It was certainly a flip cell phone. Although Dennis,
Welcome to the channel.
Scorpion Fire, thank you for the follow. Welcome to the channel. Dennis, All Hail the Laser God, still uses a flip phone. You texted her, she got a phone before you? I don't remember. I think I got a phone because she got a phone. I can't remember that part. I just remember we both had phone. Seth. Thank you. How are you doing, Seth? Thank you so much for the Prime. I hope you're having a good break. Are you ready to start again? But I'm glad that, I do hope you're having a good break. I hope your classes are more kind to you than the class that I was responsible for. Yeah, so if you are just getting here, this is different content than I'm used to. Usually on Sundays we're building physics demonstrations, we're doing things like that. And talking about physics, lessons, math. But today we're just doing an AMA. I have a bunch of questions from you guys that I'm going through. If you have a question, exclamation mark ask, space, and then the question. If you want to know something about physics, I used to be a chef. If you'd like to know about chefing or cooking, I worked for an Iron Chef in New York City for about 6 months. So if you want to know about that lifestyle, which was really a lifestyle, then today we are building our relationship. We are. My relationship with Tish Chat. And that means a lot to me because I was talking to my wife about it, and my community means a lot. This is awesome. This is awesome that I can just hop on and just chat with you guys, and that I don't have to have rigorous physics planned. Pushing boxes up inclined planes. The physics of cooking streams. We did a couple of those. That was a lot of fun. I don't know if I'll do a lot of physics lessons when I do the outdoor cooking stream. Right now it's 5 degrees. I think it's like 5 degrees. What's the temperature outside? Did someone say box and ramp? I know. If I don't push a box up a ramp for a week, I wonder if people will be upset at me. And you guys are, I guess it's a little bit warmer than I thought. I guess it's 19 degrees. So it's 19 degrees, but the sun is shining. I think it was like less than 10 this morning when I left though. Okay, so that's how I met my wife, and that's some stories about my wife and I. Our first kiss, I'm going to tell the first kiss story. Our first kiss, she said, what did she say? She either said no or stop. And then to this day, she swears she forgot that she said that. Because it was a consensual kiss. It was a great kiss. It was perfect. It was exactly what you would expect from movies. And then she says no or stop or something, but I think it was because she heard something or like a twig broke or something like that. And she swears that she never said that. And I swear that she did. And I apologized so profusely afterwards. And she was so confused as to why I was apologizing because it was totally perfect. And she... And I guess, I don't know if she blanked out or if I blanked out and I heard voices or something. Or if there was a person who was actually really close and they saw us and was like, no, stop. But I don't know. It was terrifying for a few hours, and then it all was better because it was just a misunderstanding. I always like to rub that in her face, too. I don't think she likes that story. I don't know if she's listening or not right now. If you were listening... If you're listening, honey, I love you. And I had to tell one embarrassing story. We were Spider-Man. Got to hang upside down, weren't you? No, this was before the Spider-Man incident. Oh, man, that was funny, though. But no, it was perfectly fine. It wasn't, weird or creepy or anything. It was great. And I just like to bring that up to embarrass her. I think I've embarrassed myself more. What's my favorite meal to cook? Okay, what's my favorite meal to cook? I don't know. I used to really like to eat pork. I'll be honest with you. I really liked pork. His wife was the news reporter. No. But yeah, so I really like to cook pork until I couldn't eat anymore. So now I don't cook it anymore, and I don't like it. The taste is good, but it makes me sick. So it's called getting old. You say cooking some kind of sauces or something? I do really like to cook. I really like to make salsas. So fruit salsas and whatever. But that's just because you can put tons of flavor in them. Lots of acid, lots of vinegar, lots of sweet. So it really hits all of those notes that I was talking about before that I like to eat. It comes out of those salsas. So tomato salsa or salsa verde, which I don't really ever make. I think I made it a couple times in a restaurant. But all sorts of fruit salsas are really good. Any type of fruit, or I shouldn't say any type of fruit, but most fruits go really well in salsas if they're really acidic. And you can pair them well with onions and cilantro and stuff like that. So a lot of that type of stuff just has really, really good flavors, and I like making it and like eating it. And then whatever the protein and stuff. I like to cook salmon. Salmon is probably one of my favorite proteins to cook. I just like the way it looks and tastes and how you can give it like really nice sears. And then it pairs nicely with any salsa that I want to make. So there's that too. So that's that. Okay, so Tyrion has a couple questions. When was the last time I jumped into a lake? That same time that my brother told that story. That was the only time that I ran and jumped to a lake on accident. On purpose. I used to swim in lakes all the time, but not anymore. Oh, my parents live on a lake, and I swim in that lake. So last summer, I jumped in lakes on purpose to go swimming. And so did my kids. My two oldest kids are official swimmers and love swimming. So they jumped in a lake as well. Thank you for asking. Do you ever get tired of losing at Pokemon cards? No, I can lose. All I do is lose no matter what. That's definitely, that's my motto. Have I tried mango, pineapple salsa, and pistachio salsa? I have not had either. It sounds gross. Mango, pineapple, and strawberry would all be really good. Pistachio would be weird. If you put those four together, it wouldn't be savory. But mango and pineapple and strawberry all on their own make great salsas. All together would probably make a fine salsa. Spangle 007, thank you for the follow. Welcome. The pistachio would make it a dessert salsa in my opinion, which would be okay. But those four things sound great together as a dessert. Never as savory though. I don't know how that would work. Pistachio is too weird. Have I tried it with some Thai chili sauce? In that situation, I like sweet chili sauce. Still don't know if the pistachio would go. Maybe. Still don't think it'd be savory, but maybe if you start to toss it. So you could use some pistachio. You use pistachio in some savory dishes. I can see that in some like stir-fry situations. But I don't know. Now that you say that, maybe. If you just have the right sauces in it. Maybe a little fish sauce in the stir-fry with the pistachio and some fruit. Salmon. Ooh, yeah, definitely. Sweet chili and soy on top of the salmon is fantastic. Alright, so, Zoiku asks, what could possibly explain why anyone who knows how to cook choose to eat Stouffer's? I don't know. I told you it was a guilty pleasure. I did say it was a very guilty pleasure. I'm not proud of my Stouffer eating ability, but it's there, and I can't deny it. Yeah. Stouffer lasagna is good. It is good, and it's. I don't eat it often. Like I said, maybe once in every 2 months or so, if that. And you can make your own lasagna, and making your own lasagna is going to be really good too. But yeah, it's not. I don't know if I would. Yeah, I don't know. It's like you call me out. Which of the Spice Girls would you be? What Spice Girl would I be? Time. I think that goes without saying. I'd be Time. Got too much time on my hands. I would get a really big bottle and put myself in the bottle. You know, if I could save time in a bottle. Okay. Justin has a great question. What is the best criticism you can make of your own research program? Say from the perspective of an outsider, how would you refute it? And how would you refute it? Of my own research program, like at my school? Is that the question? I have heard this. I have made this argument, and I've had a really good ref of what I do specifically. Oh, what I do specifically. So I work on something that's really not practical. Yeah, that would be my biggest argue. This is what gives me problems. Because I work on something that's really not practical. And so my argument is that people who are my age shouldn't be straying so far away from practicality. And that's because it's not immediately practical. If it's practical, it's not physics research, it's engineering. Oh, no. Oh, that's funny. Yeah, and that's exactly it, Haney. If I could give myself an argument, that would be what it is. For why someone in my situation should not be doing what I'm doing. Resident sleeper. Everybody talks about it. Like, everyone's just like, oh, it's nice to, like, not be practical. However, like, there's extensions of that, right? Like, someone who works on, like, topological insulators or something that's maybe a little bit more mainstream might not be doing something that's practical, but at least there's some, like, obvious gateways to practicality, you know? People that work on, you know, string theory or something, like, again, part of what they do is try to find reasons to be practical, you know? And, like, that's... I don't think there's string theorists who don't care about practicality. Well, I mean, that's probably a wrong statement. That's probably just a flat-out wrong statement. There are probably string theorists that don't care about being practical. But I think the majority of string theorists would care about being practical. Yeah, string phenomenology, exactly. I think the majority of string theorists care about being practical. And honestly, I don't with my project. And I hope that it is. And it could be. Castellano, stop. But yeah, I couldn't tell you I can't tell you whether or not there's a lot of practical application. If you're an established physicist, it doesn't matter as much, right? But if you're a young physicist, it kind of does to some degree. And then, my fight back, my how would I refute, and that is because I'm studying a real problem that we don't understand, that people have been talking about since the beginning of time. And I won't end the problem, and, you know, the people beyond me probably won't end the problem. You know, it's a big, big problem, and we will always need people to always continue to work on it, or else we won't ever continue to finish, or make progress in the field. And I think that's it. I think that's what I would say, is we're always going to need people to continue to work on it. And the longer I work on it, the more successful I'll be at it. And if I start working on it when I'm later in life, that's making me less successful on it. So I'm starting to work on it now. Because I could just do, like, so David Albert is one person that I always think about in this situation. David Albert is a physicist, or a philosopher of physics out of Columbia University. And he wanted to do that. Like, he wanted to do fundamental research that didn't necessarily have an immediately practical application. He studies time. Believe it or not. And fantastic researcher and author, public speaker, the whole works. And he, his debate with Tim Maudlin is one of the best ones to keep your eye on if you like what I like. And his ongoing friendship in debates. And his PhD, he always said he wanted to do fundamental stuff. Thank you, whoever's in the queue right now, for handling that. He always said he wanted to do fundamental stuff, but nobody would let him. And, I mean, that stinks, right? That's just miserable. But, like, so he did a PhD as quick as he could, and then went and found a job doing something he wanted to do. And I think that's awesome and fantastic for him. And that would be, like, an example. And, like, I would expect people to say that to me. But people don't. I think people recognize that the problem of time is something that's going to require a ridiculous amount of research. And you need to start at a young age and be kind of dedicated to it for the majority of your life. Luckily, it spans many different fields and many different areas. So you don't always have to stay in one place working on it. But last time I was working on it in causality. Last project I was working on it in causality. And now this project, I'm working on it in quantum computing. Both of the things that I've thought about for a long time. But people work on it in cosmology and general relativity. That stuff I'm a little less familiar with. But let's see what Devil Honor says. Don't worry, Eric, if things don't work out, getting poached by Google isn't so bad, right? That's Another reason to have quantum computing in my name, in my title, that way I can at least, reach that field of people interest. But great question, Justin. I might bug you on Discord for yours. For your answer. Tyrion, if you were one of the Beatles, would it be Ringo and have the other guys hate you? Thank you, Tyrion. Kerwer says, Tyrion, what are you doing? Hi, QST. Good to see you. Cosmolano. What's my favorite country? I'm not really a nationalist. Exclamation mark. No, not your answer for how to attack me. Actually, yes. Justin, send me a message on Discord with how you would attack me and how you would defend me. And then give me yours. Attack and defend for your project as well. I'm not really a nationalist. I think that America has a lot of good things and a lot of bad things. I don't really know a lot about other countries. I don't have a favorite country. If I could say my favorite place to visit, or a favorite place I want to visit, my wife and I have been talking a lot about seeing the castles in the UK. I would love to see the castles in the UK. I would absolutely love to see the castles. In fact, all of Europe, I would love to see castles. Which I find beautiful or else. Yeah, favorite place to visit. Yeah. I really, really want to visit UK. And go and do a castle tour. That would be amazing. Yeah, so what is my favorite country? As far as like developments and stuff goes, I like being an American citizen. I think it's fantastic that I have this opportunity. I think America's given me a ridiculous amount of opportunities, and I'm forever grateful for it. And I do at some point wish to continue that going. But I'm not like diehard American like all these, like, I shouldn't say all of these, like some crazy people. I'm proud of my country in some regard and disappointed in other regard. But as far as visit goes, yeah. You live about 0.4 miles from a castle? Oh my goodness, Templar. You're like in castle zone. That's where I want to be. The UK got castles. I know. I want to tour them. I want to look at them. Especially when that grass has universal healthcare on it. My castle is always open to PhysicsOH. That'd be awesome. I would love to do... if TwitchCon's in person, I'm planning on going. And I would love to have some meetups and stuff. So we'll have to talk about that when it gets closer. I know it's not until next fall. I hope it's on. I hope we have everything under control by then. Why would anyone study time? It seems boring. Again, can anyone guess who asked that question? Oh, come on, Tyrion. Blackman has a good one. Thoughts on licorice? Black licorice. Red licorice? I like it. Black licorice? It can burn. If someone said, hey, there's a shortage of black licorice, my first reaction would be, thank God. Just get rid of that. Black licorice is just garbage. Burn, yeah, burn. Burn the licorice. In a controlled and environmental fashion. You mean like a fire? Yeah, what did you think I meant? Some Dutch drop? Oh, I don't know. Like, I like fennel and, or anise, you know? I think I'm saying that right. Anise? They're okay in certain situations. Like brines. And other things. I think you thought it was spicy. Maybe go to a doctor. It's spicy because it makes me feel bad. No thank you. Black licorice. Blah. Where does charge come from in a particle? That's a good question, and honestly, we don't know. Charge is treated as a coupling constant in quantum electrodynamics, and we don't know where coupling constants come from. So charge, as in like all of the things that we see about particle interactions, are really due to charges, right? And whether it's color charge or electron charge or help me out here. The other charges, they're all due to like coupling constants, and we don't know where they come from. or came from. And like people have tried really hard. You could say instead that it's like weighting on a coupling constant, that you're basically asking why is matter in a particular representation of a gauge group. You could say that. I'm gonna try to make it a little more accessible. But yeah, it's and by that he just means like what the different types of like Lie algebras and like the different groups. The stuff that we talked about the other day with the group theory stuff, where you have like the different gauge groups, and then well, I'm not gonna just repeat what he said. He said it fine. But yeah, so it's like the different charges are the weighting of the interaction, and that's the best we can do for coming up with what charge is. Like we don't really know, other than that, where charge. So mass charge is something else. Maybe the interaction with the Higgs. Bye, science streams. Thank you for stopping by. Go make sure you go give a follow to science streams. Science streams also stream science and some games, and they do interviews and lots of good stuff on their site. So make sure you go give them a follow. John Gwynn, thank you for the follow. Welcome, welcome, welcome. Like I said, if you are new to my channel today, we normally do a lot more rigorous physics stuff, or like not necessarily rigorous, but like just more physics-oriented content. But today we're just hanging out and chatting. So, oh, Devil Honor, thank you for the follow. You've been chilling for a little bit. Thank you, thank you. How much beer do I need to drink until string theory makes sense? Good question. Justin doesn't drink any, so I guess maybe you need something else. Something a little stronger. No, string theory is interesting. And there's a lot of good motivation to study it, in my opinion. But yeah, so charge, where does it come from? I don't know. I don't think anybody knows. That was one of the things I said on Discord a little while ago, is Atiyah. Michael Atiyah tried to prove it recently, and unfortunately it turned out that it wasn't very good. Many people have tried to prove it, not so recently, and all of it has led to not understanding where it comes from. Sal for the Furbolg. Furbolg, nice. Thank you for the follow. Welcome, welcome, welcome. So let me see here. It's just ask, but I see it, Admiral. Maybe I can keep up with it. I'm gonna keep going through the list though. Let's see, there's John. When you drink coffee, how much rum do you use? None this early. Do you use either string theory or loop quantum gravity in your time study? I don't, Haney. I actually don't think they're relevant. Not yet. I think we don't know enough about it to know if it needs them. Now, loop quantum gravity, whatever it is, it should come out naturally. String theory is the other way around. I think loop quantum gravity is background independent, which means that time, whatever we think about time, should come out of it nicely. Whatever we find out about time, we should be able to use in string theory. But, yeah, so loop quantum gravity will tell us about time. Knowing about time will tell us about string theory. But not, but you can't, but unfortunately I don't think right now, there's any reason to be working on time in those. Now, string theory does have, the ADS-CFT people can claim to derive time. Really? Okay, so ADS-CFT, though, is different. I mean, that may be strings, but I think it may be strings. But ADS-CFT is very much, like, dedicated to learning about the structure of the universe, which would mean it would be very different, right? And is that right, Justin? That they're kind of like, they're talking about the structure of the universe with anti-de Sitter space, the conformal field theories? No longer about just string theory. Okay, I didn't know that. I thought it was. But yeah, I can't. So we're in a place where we know so little about the nature of time that I feel like we're not ready to apply them to those deep subjects yet. Not yet, at least. Hopefully, like I said, hopefully in my lifetime. That would be amazing. Okay. But no, I don't think they're relevant. Yeah, I think we need to find more about it before we know where it will fit in. If you came up with your own universe, what would you keep from ours, and what would you change? Wow, that's a question. I don't think you're allowed to change anything. Like, in all honesty, I don't think you can change stuff. Oh, man. I don't know of a single thing that you could change that would be okay. Everything seems like it works just because it's the way it is. I don't know. Great question, though. Great question. I don't think remove the laws of thermodynamics. Like a forward and backward dimension of time. You would add a spin 3 field. What if it screwed everything up, though? What if it interacted with other spin fields? I mean, we have a spin 3 field in the way of. Can we do that? Can we do the spin 3 field? I don't know if we can or not. As a you know, whatever it is, like non-constituent or whatever. Constituent? Composite? Unitarity and things? Oh, so I guess a fundamental one. Yeah. Unitarity and things. Exactly. That's what he wants, Justin. That's what he wants. I did go to a talk one time at Cornell where someone was talking about how spin 2 is the highest field you can possibly have in our universe. And it was really, really interesting. I didn't understand it at the time, but it was really, really interesting. Okay, what's next? But that's really, really good. Haney says, is it possible to fry chicken without eggs? Absolutely. So oftentimes what you want to do is if someone is allergic to gluten, eggs are... Okay, so there's a triple breading method, right? There's triple breading method. And it usually goes flour, egg wash, or milk wash. So that's one way to get rid of the eggs, where you can put it in just milk. And what you're really doing is coating the chicken in flour so that it's I always like to think of it as like a fresh, dry surface, right? And then you put it in some egg wash or milk wash and get it ready. It's actually !ask Templar. !ask space. I think it was questioned earlier, and then we changed it at some point a while ago. You can use buttermilk too, like John Gwynn says. You can use buttermilk too. Very good, definitely. But oftentimes what I do is if I'm serving someone who's gluten-free and I don't even want to bother with the triple breading, I'll just take the chicken and just throw it in like Kellogg's, like cornflakes. Just crush up a ton of cornflakes, throw the chicken in cornflakes, and then fry that. And it comes out really good. Now, a couple things is most of the time, if you're doing it in a frying pan, you oftentimes cannot cook it thoroughly all the way through. So the goal is to butterfly. So you take your breast, right? You take the breast of chicken so it's like the smooth side up, okay? Flip it over. Then you're going to see like a crease in the middle that kind of goes diagonal through it with like a little bit on the one, like a little bit, it's just a crease. It's not anything more. So then what you want to do is get your knife and go underneath it until you're like as close to the edge without cutting the edge off. Okay? That's folded over, okay? And then, so that's the one half. Then you take the other side, and now it's flatter, so you can get your knife really good in there on the bigger side, all the way, pull it, it's really just like a dragging motion if your knife is sharp enough. And then open that up. Now you've butterflied the chicken breast, so it's nice and big. Now, if you're really concerned about like cooking it thoroughly and like you don't have an oven or something like that, then I would cut that in half, put some plastic on both sides of the chicken, and pound it out, okay? And then it's nice and thin. The issue here is that you want to make sure that it's cooked through. So if you're not worried about like, I mean, sometimes you put it in the oven the wrong way or something, it could get soggy. There's a lot of things that could go wrong that would be nice just to cook it from start to finish in a pan. But anyway, so now that you've butterflied it and you have it as thin as you want, then I would honestly just crush up a bunch of cornflakes, toss it in, and then cook it. Get a pan, put some oil in it, get it really hot. One side, the other side, oven it. Put cheese on it if you want cheese, something like that. But yeah, you could definitely you definitely cook without egg and bread something to fry it, either in a pan or in a deep fryer. If you deep fry a chicken with cornflakes, I would probably turn it down a little bit, turn it down to like 300 degrees and not do it at 350, because again, it's gonna scorch the outside while the inside's still raw. So maybe 300 for that. And worst case scenario, I mean, I've microwaved it before. Cook it in until it's as dark as you can get it, and then just maybe slit it, look at it in the inside. I mean, it's just for you. You're not cooking for like Ramsay or anything. Slit it, look at the inside. If it's still raw, just throw cheese on or something, toss it in the microwave for 30 seconds. It will be fine. Oh yes, and you can do crackers as well. And egg whites do work as well. Yes, I was reminded of these as well. Yeah, so so crackers and are good for breading stuff, but they're also glutinous. So I guess I was talking more about gluten-free, even though you asked about no eggs. But either way, I was trained in cooking a lot for vegan and gluten-free because I worked in an eclectic restaurant that was the menu specialized in vegan and gluten-free. So I have a lot of training with that type of stuff. And then I have lots of training in like traditional. I have 6 months of training in traditional French, so it's not a lot. So let's see. QST asks, what kind of physics lie behind the working principle of linear motors? Do I know that? Principle of linear motors? I don't know if I know that one. Linear motors operate with AC power supply. Supercharged, also rotary servo motors. The linear motor primary part is connected to the power supply to produce a magnetic field? It's magnets. Yeah, I guess. Ampere's law is involved. There's no way any of these physics questions are actual words. I don't know. Linear motors just sounds like words to me, but I just didn't know it was a thing. Yeah, apparently, I guess it's AC power supply, and it has a lot to do with magnetic fields. I don't know. Sorry, I wish I knew more. Wait a second. Is this one of those things where, like, you can propel something along a magnetic rail? Is that one of those things? Like, they have them as, like, is this the type of, there's like a, what is it? We talked about this a couple times, a railgun. Is there a railgun that works off a linear motor system where you just propel it along magnets? Is that the same thing? I'm not sure. I'm sorry. I'm sorry, QST. Don't know. Maybe that's a Discord thing. What is a really stupid question? Is that what it is, or stooid? It says stooid, but I'm assuming it means stupid question. What's a stupid question? I don't think there's a stupid question. I have a stupid question. Can I ask a stupid question as long as, or can I tell you a stupid question as long as nobody gets bothered by it? It's not bad, I promise. But a stupid question, in my opinion, a stupid question is, what is your IQ? That's just, it's so misled. If it's not like a GQ catalog or whatever, I don't know, is GQ a thing? I just made that up. There's something letters with Q in it. And then like cosmopolitan or whatever. If someone's legitimately asking you what your ID is, that's not a question worth asking. In fact, usually if someone's asking you what your IQ is, it's done in a way that's inappropriately aggressive, in my opinion, which is why I would think it's stupid. Now, I guess there could be people who really don't know that it's not a good metric, that it's really not a good thing, and in which case, it's not. It's not a stupid question. If someone's genuinely confused about what it is, then it's not a stupid question. But oftentimes when someone asks me that specifically, it's in a very aggressive and like an attacking question about a dead metric that doesn't make any sense. So yeah. So oftentimes, if someone is aggressively asking you what your IQ is, that's a stupid question. Other than that, I don't think there's many stupid questions, if there are any. And like I said, there's some people who genuinely think that IQ is a good metric and might ask you that. What is the signature of this dead metric? Excuse me. That was really funny. Yeah, so anything regarding IQ is useless. Don't listen to anybody who thinks that people should be grouped in IQ as a dead metric. What's the sign? Plus. But that's more of a joke anyways. I don't really mean that sincerely. That was more of a joke. What programming languages do you use in your physics career? I saw that you use Mathematica. I've done some with Mathematica. I've done a little bit with Python, but honestly, I'm probably one of the farthest. If you rounded up all of the theoretical physics students and put them in a ranking of who uses computing languages to who doesn't, I'm way in the bottom. Like, I don't use computer languages hardly at all. I'm not proficient in any of them. Yeah, NC has a website. Plug your website, NC. With a lot of Mathematica stuff on help on it. A very good resource if you are interested in those languages. And he also streams Mathematica sometimes. So if you're interested in that, give him a follow too. And pay attention to when he's going to stream some Mathematica fun. But yeah. Programming is for nerds, says the person who's a professional programmer. My IQ died between 18 and 23. I tested real high. But yeah, but they don't really matter, you know what I mean? Like, they're not real. Lots of mischief in those years, maybe it's linked. It's not linked. It's not linked because it's a dead metric. Yeah, IQ is not good at determining literally anything, Templar. If you want to associate an IQ with who you are, then you're misinterpreting who you are. Yeah, that's my advice. That's my ideas about that. Okay. Well, what's my greatest weakness? Black licorice. No. What's my greatest weakness? Believe it or not, I would say that I'm not very self-disciplined. And I've gotten better. Wait, I tattooed my IQ. IQ greatest predictor for real. Yeah, so I assume that's not for real, but maybe it is. Like I said, yeah, it's not. Well, no, let me. I gotta remember this. Stay focused. My greatest weakness is probably my self-discipline. The way that I combat that is I force myself to work a lot, and sometimes I have good work and sometimes I don't. But I would say if I could focus and be I mean, you guys know my focus is all over the place. We just watched it. I wish it was better. I wish I was more self-disciplined. But it's something I struggle with, definitely. And probably my greatest weakness is my self-discipline. In my research, I would say. I had a lot of problems with patience and struggling with stuff like that. I think I got a lot better when I left the restaurant industry with my patience and stuff. It was an incredibly toxic environment, and I was not cut out. Well, I was cut out for it, but it was doing a lot of damage to me. My greatest weakness is this stream. Emerald, can you explain how fermions work in string theory? No. I'm sorry, no, I don't. They're different though, right? Like bosons are brains, and fermions are loops. Is that right, or just different dimensional brains or something like that? I don't know. Justin, help. I'm not sure how fermions work in string theory. I'm sorry, I don't know anything about string theory. You moved away from a ton of stress and got more patient? Yeah. It was very, very toxic. We were talking about it. Okay, cool. I've been missing some of chat. I'm sorry if I'm missing chat, guys. This is I'm focusing on the queue, so if you do have questions, put ! Ask a space in your question. Awesome. Thank you, Justin, for helping. Yeah, I unfortunately, that's beyond me. Justin already knows. Justin, knows when to take over a question because he knows when I'm lost. And thank you for my mods who keep managing my queue with me. I appreciate that a lot. So, and I love that these questions are flowing. I do want to get to Jax's questions. So come 3 o'clock, I'm going to start handing out Jax's questions because Jack asked a bunch of brilliant questions, and I want to make sure that I speak on those because they were fantastic. And people will probably be interested in hearing them. Haney, I heard there were 3 real quarks in a neutron, and a bunch of virtual particles. Are the real quarks always stable? I think the real quarks are always stable. They're always stable, and they're always stable in that configuration as well. It requires a lot of energy to knock them out of that configuration, as far as I remember correctly, especially for neutrons because they're neutral, if I remember correctly. And protons as well, I think, are stable, even though they have a non-zero charge. Maybe someone can help me out a little bit with this one. But as far as I'm concerned, I think that neutrons are very stable, and you need a lot of energy to break particles out. I think proton is a little less stable because it's charged, but again, I'm not 100% sure, so don't quote me on that. Maybe we could look that up. And the only reason I think they're less stable is because they use them to smash at particle colliders, and I would imagine the less stable are, the less energy they need to get good collisions. Okay, so what is more stable? Proton or neutron? Which is more stable? Nuclides contain even numbers of both protons and neutrons, are most stable, and this means less radioactive. Either way, they're both stable. I'm just wondering which one's more stable. Isolated neutrons are not stable. When I think of stable, I mean decay. And a neutron will not decay into quarks. Perhaps the most stable bound system in the universe is a proton. Maybe, does that make them better for colliding? Is there a neutron collider, or are they... Yeah, I'm thinking about none of them will decay. At least as far as I know, unless a neutron decays into something else. Let's look it up, though. I don't want to give you guys wrong info. Are 11 minutes. Outside the nucleus, a free neutron is unstable. What's it decay into, then? Oh, okay. So it goes into a neutrino and electron. I see. Through a W interaction. Is that right? So what was the question? Wow, I had that wrong. I guess in the real quarks are always stable, but I guess the neutron. So even your question didn't even ask about that. Your question was just asking about the quarks. The quarks are always stable, but they'll go into different configurations. You can't have a quark by itself. It might, like in this interaction that I'm looking at now for a neutron decay, it should decay into a neutrino and an electron. I think about neutrinos while I was looking for proton decay. Still haven't seen proton decay. Yeah, the length of a proton decay is like... neutrons are hard to use in experiments because off the bat they are not charged, so you would have a hard time accelerating them. That makes an awful lot of sense. Neutron decays to a proton after flavor change of a down quark and an up quark. Okay, I see that now. So it goes to a proton and an electron and a neutrino. Or a proton W, and then the W goes to electron neutrino. I got you. Interesting. So the W... Okay. So this is something that I didn't know. I just assumed neutrons were stable because they couldn't decay into quarks. But I guess I didn't think about them decaying into other... or a proton and then other fundamental particles. Weird. Weird, man. Yes, in that situation, Haney was asking about confinement. But yeah, so confinement's different. So that's something different. Yeah, so you can't get quarks by themselves. The weak force was always strange to me. So it's the strange force. What surprised me is that the internal configuration of quarks and protons and neutrons suggests that this is much more complex concept than just a proton and a neutron. I would say it is, but we gotta know that, right? We know that it has a lot to do with the gluons and the way that they behave. And like the fact is that like one of the biggest killers of the gut model is that protons don't decay. Right? I know that. I know that's a bit of history for you. I don't know. We can't see them because the energy to pull them apart is enough to create new quarks. Seems suspicious. come out of the way of the configurations, right? The configurations of quarks means that the eightfold way is real. You know what I'm saying? Like that has real quarks. And when I say real, we call them real is because they're like the fundamental real thing that you can use in calculations to, you know, get all the different particles that we see in experiments. Can't get them isolated at current achievable energies, at least. That's the most conservative and accurate statement for sure. Okay, let's keep going though. But yeah, I guess I learned something. So even your question was legit. I just answered it with an incorrect answer. So thank you guys for correcting me on that. It's important that we make sure we say the right things here. So yeah, so neutrons aren't stable. They'll go into a proton, electron, and an electron neutrino. Okay, good question. NC says, should computational physics, be a new type outside of experimental or theoretical physics, or stay under theory? So I don't really see it as theory anymore. Maybe you guys do, but in my institution, we really have like 3 groups of physicists. We have experimental, computational, and theoretical. Like we don't have, like in my institution, and this is just, and maybe I see through rose-tinted glasses, but in my institution, we actually have a group of computational physicists who refer to them as computational physicists, and they don't refer to themselves as theoretical physicists, so we don't refer to them as theoretical physicists. They kind of fall in the middle of both, and have great successes doing what they do. But like again, like I don't see them as the same thing as what I do, and they don't see what I do as the same thing that they do. I'm interested in your guys in your input though, because computational physicists often do work with both theoretical and experimental to get results because they need it. 3 groups of physicists: theorist, experimentalist, and that one grad student who talks about time. Oh, man. Brutal. I think they would have a home in the complex systems department. They speak different languages. Always muttering something about a Tyrion. What is a Tyrion, and why does that guy always talk about him? So I saw a beautiful lecture of Susskind on explaining black holes exist to our current understanding. The notion that the event horizon of a black hole is pretty much a holographic display of everything that fell in to not destroyed and its information. Yeah, I've seen that as well. Did it cut that off, Cyber? Is there more to that question? Is that just a statement? Because I've seen that as well. It's a great idea. Susskind has formulated using string theory this idea of a holographic projection on I think with Maldacena actually on but fact check me on that one, guys. I think it was Maldacena and Susskind about the holographic theory on a black hole. It's really a beautiful thing. I'm not 100% sure of the validity, but it's really, really nice. And I do hope that something of that nature comes true. BSD, good to see you. Good to see you. So yeah, if there was more to that question, then go ahead and ask it, Cyber. But I like that. It was a really good theory for sure. What's my favorite planet? Mars. Oh, okay. So EER equals EPR is most. That's right. To Hooft and Susskind came up with the holographic principle. Okay, so I mixed up Maldacena and to Hooft. So to Hooft and Susskind came up with the holographic principle. Thank you. To Hooft was first, but Susskind had a better title. And then Maldacena, yeah, that ER equals EPR. Very good. Thank you, guys. Thanks for that. My favorite planet is probably Mars. I want to know more about it. A corny answer because I'm not an astronomer and don't have, or an astrophysicist and don't have a lot of experience with them. But great question. But Mars because I think we're going to get the most answers in a reasonable amount of time, in my lifetime at least. I got a question. This is from Templar. Pretend you're speaking to a dum-dum with no formal physics learning. Can you talk for a minute about what time is as we understand it, and what actually is it that we need to know? Because I got entropy and gravity wells. What are? Okay, so why is time an issue, and why do we talk about it? And here's my main rundown of why time is a problem worth studying. Okay, and this is it. The world is quantum mechanical. We know that. The world is quantum mechanical. the world is also relativistic. We know that. And relativity and quantum mechanics don't necessarily play nicely, but we don't know if that's on purpose or not. And there's a lot to say about time in this problem, and that is namely that in quantum mechanics, we don't use time in the way that relativity uses it. We don't use it as a parameter, or we don't use it as a dimension, we use it as a parameter. Enter quantum field theory, where we do use time as a parameter, or as a dimension. We do, but we also have this very ad hoc time ordering operator that's sort of added to kind of clean up a bit of a mess that we have. And some people might not say it's a mess, but it's a mess. If you want to know about the fundamentals of why things behave the way they behave. And I get that ad hoc method works, okay? Divorced Uncle, thank you for the follow. Welcome, welcome. I get that the ad hoc thing works. Don't get me wrong. I get that it works. But it's not satisfying to a lot of people, okay? Regardless of that. Doesn't matter. Why can't we get general relativity to work with quantum mechanics? And my answer revolves a lot around time, okay? And moreover, I think the problem that I have even more so than that is that we don't understand why the second law, or no, I don't want to say the second law, third. We don't understand why the arrow of time is a real thing. Why causality goes the way it goes, and we don't have any control over going, backwards in time. If you were to ask me, well, let's not get into that.
Now
yeah.
explain it with entropy.
That's the problem, is entropy. Entropy is always increasing in a closed system. In a closed system? In an open system. In a closed system. In an open system. Something like that. Or staying the same. But the second law of thermodynamics is true statistically, and we have to go with it. Right? Levi, thank you for the follow. It's true statistically, and we have to go with it. Why it is the way it is, I want to know. If they can do it, if we can get to the point where we know why it behaves the way it is, I think a lot of this problem with why quantum mechanics uses time as a parameter and not as a dimension will come out naturally. And maybe that's an inkling, maybe it's just, I'm not the only one that thinks it. So, hey Jack, good to see you. Good to see you, good to see you. I'm not the only one who thinks it, and I think that there's a reasonable problem there to be solved. Yeah. Here, let me move some of these questions over really quickly. I don't want to lose them. We're getting into the heavier physics questions, but yeah. So if that's the idea behind, that's my idea behind why time is important. Is like I don't think we're gonna get anywhere with understanding quantum mechanics until we understand the role that time plays in it, and that's the biggest thing. Okay, let's see here. What was first, chicken or the egg? Something that looked like a chicken. Yeah, something that looked like a chicken and laid eggs. I don't know. Yeah, I'm not by myself on that one. I'm not like, hey, I'm out left field trying to study this by myself, Template. There's a lot of people that work on this problem. And I don't say a lot of people, but there's a handful of people that work on this problem. And people come at it from all different angles. I'm coming at it from quantum mechanics and quantum field theory. And a lot of people come at it from general relativity and cosmology, which I think makes a lot of sense. I don't think many people look at it from time and from quantum mechanics, quantum field theory, but there are a handful of people who do. And that's the part that I'm interested in. Let's see here. What's my favorite thing to do besides physics? Music. I love music. I listen to music. I play music. I sing. I love music. Those are things about me. The majority of my time, physics and music unrelated is with my family, and that I have a lot of fun with. But like if you're just asking about me, particularly family aside, music and physics make up the majority of my life, and that's that. What books do I like to read? I mean books, not textbooks. I'm not much of a reader, honestly. I like to read about historical physics stuff. As you guys know from our new series about Old Man Reads Old Books. I play the acoustic guitar. I don't play the electric guitar. I don't play guitar very much. I don't have calluses really anymore. Usually I can only play for an hour or two before I start to have before my fingers start to hurt. So I'm out of shape with the guitar for sure. And I can't pick anything. It's just chords. And like, blah blah blah. But yeah, it's mostly if I play anything, it's to accompany voice because I see myself as a vocalist more than anything else. Yeah, I don't really read books. If you guys like history of physics, I have begun a new series on Wednesdays called Old Man Reads Old Books, where I take a look at old books and read history about them and talk about the things people were thinking, the things people were doing, and draw inspiration from that. And I put them up on YouTube when I'm done. So you can check those out on YouTube. The last person we did was Vicky Weisskopf. That video went up last night. That's a fantastic physicist who inspired many, many people. And then a day or two before, we'll play like Principia and Galileo stuff. Actually books that I own, so no. I don't think I own a Principia or Galileo, but that'd be fun to read. Trust, I would love to do that. If I get my hands on a paper, on some sort of reprinting or something of that, I would love to read that. But usually it's just books by theoretical physicists from like the anywhere from the 30s to the 70s. Usually somewhere in the middle of that. Definitely. But yeah, I don't read books, unfortunately. And it's not because I wouldn't like to, it's just I usually spend my time doing other things, either relevant to the stream or relevant, or just music, which is not that. What do you consider the most interesting place on Earth? Can be man-made or natural? Wow, what a great question. Wow. I haven't been very many places. If I could say a place I haven't been to, I love mountains. I just like being able to see. If you go up on the house where I grew up in New York, if you go up on the hill behind my house, like my house was on a hill. If you go up behind it, like and walk straight up, I live really close to there now. But when you go up there, right, you could look out over and you could see 2 cities past mine. And being up there was like surreal to me, like absolutely surreal. Gene Archive in the Arctic. What is that? I'm just going to type that in here and look at that later. That just sounds fascinating. I just love to be able to see for miles. I don't know what that is. I'll have to look at that. Okay, let's keep going. These are great questions. I did not expect this to be like this, guys. Thank you for all the great questions. I really, really love them. I still want to get to a couple things of my own, so we're gonna pound through these questions. I might go a little bit faster, so if I don't give you a satisfying answer, hop in Discord and re-ask. Why does your university have a graduate level class, or why doesn't? I mean, is there a reason given? No, it's we do a lot of solid state and we do a lot of computational stuff. So there's multiple solid state I think there's multiple solid state courses and there's multiple computer courses for. Bye, Justin. Thank you so much for everything, for answering questions and stuff. Don't forget to do the cooking challenge below. Where's the cooking challenge at? We're not there yet, I don't think. Anyways, but thank you, Justin. Take care. Oh, yeah, he's telling everybody else. Yes. Do the cooking challenge. So redeem your points, and I'll cook in the cold weather. I'll do a cooking over the fire in cold weather. Yeah, so instead we do computational stuff and focus on solid state and computational stuff because that's what most of the people study. Computational methods of materials is what the majority of my school is. My school is a condensed matter school. I go to Binghamton University if anybody's interested. It's a very, very good condensed matter school. So if anybody's interested in condensed matter physics, Binghamton University is a fantastic university to study condensed matter physics at. We have some very, very, very talented physicists working here. And that's what the focus of the graduate level is. BSD guy says, how do you know which spices or herbs to use while cooking? Taste. Everything's about taste. This is why, what does tails mean? This is why this is why I said I don't like to taste food after a while. Like when you go to a new restaurant, there's like a few weeks where you're tasting everything. My school is made of condensed matter. You ain't wrong. Yeah, so the, now I forgot what I was gonna say. Yeah, because like when you go to a new restaurant, you're tasting everything all the time, constantly taste. And after about 2 weeks of that, you're just done with the food there. Like you just don't want to taste things. You still have to. You don't get a choice. But it goes for a while where you actually like.
The coin flip that you're going to do right now is going to be the 1,0 state.
Oh, is there a coin flip? Did I miss it? I did miss it. We have a 2-qubit coin flip, and I happen to have 2 Pokemon coins. and I have a little spiel about quantum computing that we'll do. But that's how I know what herbs and spices to use. BSD is I've tasted a lot. I've seen a lot of different combinations, and eventually after a while you can start to like remember them, remember the flavors, and you know what to use to cook with. So like for instance, like you might not right away guess that like cilantro and strawberry are killer together. However, if you start cooking with cilantro a lot and you recognize that it goes great with like lime and other citrus stuff, and you recognize that strawberries have like a really natural tartness to them, soon you start to realize, like you just start to get those flavors in your mind and you realize that like strawberries and cilantro are like fantastic combination. Stuff like that, okay? Good question though. Asian cuisine is a little bit harder because you have very, very bold and unique flavors like fish sauce and stuff. That's harder. Not the best at it. And Indian food's really, really good, but I admit that like the Americanized Indian food is nothing. I just assume it's nothing like the like authentic Indian food, and the spice combinations and stuff that they do are probably 10 times better at least. But again, it's one of those things where if you taste, like the more you taste and the more you experience, the better it is. Smoothie, and it was utterly horrific. Cilantro and peach and grape might not be good together. You would need a lot of acid, and peach and grape do not offer a lot of acid. Okay, let's do this. So, quantum computations, right? They are.
Did you change your schedule yet?
To what? No. I told you I'd ask about the Wednesday, Friday thing, and then I was going to ask again when it was time. I just want to get two data sets. Okay, so this is the thing about the quantum coin flip, right? So we have 2 bits. I'm going to prepare them in the 0-0 state, so the black side is 0, and the colored side is 1. And what we do with qubits is we send them through a quantum computer. So I flip them and caught them. It's a random process. It's not totally random. We have some ways of manipulating the phase states that existed with our qubits. But in this situation, it's relatively random. We'll say that the things that are controlling or manipulating the phase space of our qubits are the things around us, like how hard I flip them, my thumb, the air, the coins themselves, things like that. And then what we do in quantum mechanics is we measure. And when we measure this one, we see it's in a 1 state. Okay, so far we're at a 1. Did you say it was 0, 1? Because I got 1 first. And then it can tell us, in quantum mechanics, we may or may not be able to prepare a state in a way where we can know what the other qubit is. So, for instance, we talked a lot about 1, 0. So far you're so good. So far so good. So you can prepare a state in quantum mechanics. It's called like an EPR or a Bell state, where if you measure one, you could know exactly what the other one is, and you're totally consistent with quantum mechanics. So if we measure the one, we get a 1. If we measure the other one, we also get a 1. So the state is 1, 1. And there's ways of preparing states where you can actually take a measurement of one quantum qubit, not know what the other one is, and then use it to encode some quantum information and send it to a friend. That's called quantum teleportation, and we talked about that on Friday. All the VODs and stuff. Oh, the VOD for this one's not on YouTube yet, but it will be soon. So that's that. Okay, quantum teleportation or quantum computing done with 2 Pokemon coins. Talk about nerdy physics on Twitch. So Kerwurst asks, would I fly to Mars if possible? Tempting. Very, very tempting. I don't have to worry about having kids anymore. I have 4 kids. And I'm done having kids. So there's that's going for me. Being away from my wife would be really hard. Being away from my kids would be really hard. Not nerdy enough for you. I don't know. You want me to be nerdier? How do I don't know. I'm sorry. It's not 20-sided die. It's just 2 Pokemon cards. Or coins. Being away from my family would be really, really difficult. If I was first, maybe. If I was guaranteed to come home, probably. Okay. If I was first and guaranteed to come home, probably. Just to the moon. The moon is a day trip. There and back. I'll be home tomorrow. You know, big deal. Big whoop. You know, then it's going to the moon. Hell yeah, I would do the moon. Haney said, if they can theoretically prove that axions exist, what is the process for making experiments find it? So I think Justin answered that.
I think you used that last time you lost.
Oh, maybe. Probably. I've used these in the past. They were in the garage. I had to... It's 3-way days if you're 3 days each way. I thought 13 hours. Maybe it's longer. 3 days? Either way. By the time we're sending like, the physics guy to the moon, maybe it will be a day. But if you want to go as an astronaut, it's probably going to take, it'll probably take longer. Because that's where you're going as like, as a scientist, you're going to do it. They're like the first ones there. Okay, let's see here. Yeah, so I don't know exactly.
Sorry, I forgot. You always lose at Pokemon cards. My bad.
You're such a skunk. If they can't, I'll see if I can add anything to what Justin said. I didn't read what he said. So if they can theoretically prove that the axion exists, what is the process for making experiments to find it? Is there a committee or something? So they're already looking for it in California. I know that. I looked it up. There's a great article on it, but I can't remember what it is. But hopefully Justin answered it for you. Yeah. Hopefully Justin answered it for you. 51 hours. There it is. TensorCat with the 51 hours. So yeah, so it's over 2 days. Is there a speed limit on the moon highway or something? He did. Okay, great, Haney. Thank you. I know that there's a lot of literature on it, like articles, like popular science articles, and that would be the level of my knowledge. So hopefully you got something more than that. Cryogy says, should we say that Schrodinger is in the box and the cat does the experiment? If I recall, Schrodinger hated the cat in the box experiment. Can someone fact check that? If I recall right, he did not like it. He thought that it didn't do service to the quantum mechanical system, and it was like a misperception. Maybe we can just Google it really quick. Did Schrodinger hate the cat in the box? Cat in the Hat. What? Did Schrodinger hate the cat in the hat? Really? He hated the idea of probability. So he made the paradox. I see. Thank you for refreshing my memory about that, Tyrion. Yes. Speed runs to the moon, win. I got the new record, Mom. Okay, so he hated the probabilities. Oh, look at that. There it is. There's the question, or there's the answer, Cry. Is he hated probabilities, so he made it up as an absurdity, and that people loved it. Okay, great question. Jack asked, if
You are
light
out,
doesn't...
Can I have a refund now?
Jack asked, if light doesn't experience time, then could it be possible that it doesn't pass through time dimension like we do? The issue we run into is that we see light pass through time. Well, it does pass through time in our reference frame, Jack. So that's one of the weird things about it, is it does pass through a time dimension in our reference frame, but not its own. It's a great question. But yes, it does not pass through time in its own reference frame, but it does pass through time in ours, because we have a speed limit for light. We can watch it propagate. We can take care of all that stuff. This stuff is all very, very much experimentally confirmed. The speed of light, the way it propagates, and they do it with the whole two-way. Like, you can't measure the speed of light in one direction. Crazy video, Veritasium. Veritasium did that video. Fantastic. One of my favorite YouTube videos. Simply because it absolutely blows my mind. Photons are like some celebrities. They don't age. They just get absorbed. Let's see here. But yeah, great question. If the configuration of the quarks inside the proton changes due to an external interaction, is there space for the change to be neutral or negative at some point at the change? I don't know. I don't know. I'm not sure. So it'd have to be in time, and I don't think we account for that when we do this. I don't think we account for a time. I don't think we account for a time step for a quark to be free in QCD. I don't think it makes sense in QCD, but I'm not sure. Don't quote me on that. Do not quote me on that. Now, there's interactions, but interactions are not necessarily required to happen via time step. Their interactions actually are required to not happen via time step. I don't know, John. I'm going to be honest with you. I'm not sure. That's a great question, but unfortunately, I'm not sure. My favorite physicist. Emerald Abbey says, my favorite physicist. I really liked Gelman. East Onoko. Onko. East Ono. East Onko. Thank you for the follow. Welcome to the channel. But I don't know who my favorite physicist is. I really liked Gelman. I'm very inspired by him. I think, and I'll give you the rundown of how I view old physicists, because a lot of them did a lot of screwed up things. Here's the deal. Learn from the good and learn from the bad. Every physicist did good things, and every physicist did bad things. Try to know both, and try to emulate the good, and learn from the mistakes that they made as a human. Please call you Easton. Oh, cool. Happy to be here. I feel like I'm learning a lot. Awesome, Easton. Well, usually we do a little more physics-oriented stuff, but today is just about hanging out and talking and answering questions. So I hope you enjoy this for sure. And it's good to have you here. So I would say my best answer for that is I like the history of physicists a lot, and I like to learn about physicists in the past. I try my best not to emulate anyone specific, but to learn from the good and bad in all of them. Dirac never did anything bad. Never. There are physicists that I don't know what bad things they did. You know what I mean? But I do know the good things they did, so those are the things that I try to emulate. And I just assume that they did bad things at some point. Maybe chop down a cherry tree or something. Templar, can we have so I saw this earlier. Can we sing a song as a redeem? Probably not. Probably not. I'm gonna be honest, probably not. I do love to sing. But I probably won't be doing it on stream anytime soon. Apologies. Drag, what's funny? As I just laugh. Haney says, if you could do physics at any point in the past, when would it be? And what is the topic? It would be at the conception of quantum mechanics, and it would be on time. I'd be like, wait, guys, stop. Stop, you can't make it a parameter. We've been there. We've done that. Stop, we're making it a parameter in quantum mechanics. And then everyone would be like, but it works. But everything works. You can't argue with the experiments. And I'll be like, but we've tried this. And honestly, so the first video I did on, it's on YouTube now. The first video I
Get better batteries.
I forgot to charge my microphone. Sorry, everybody. The music is pretty funky. I'm sorry, I forgot to charge my microphones. Luckily, I have two. So as soon as I realized, I put the one on the charger.
Battery charges for some dork at some point.
But these don't have batteries. I really thought they did. Anyways, what I was saying is if I could go back in time, I'd go back to the conception of quantum mechanics, and I would say, you have to do it with time. Everybody stop. Like I said, I did the Old Man Reads Old Books and on Feynman and Schwinger in this book says the way that they set up quantum field theory and quantum mechanics was doomed from the start, and for not finding a natural conclusion about quantum mechanics, for finding instead it's probabilistic, which they thought as Michael Burr. Come on, really? How bad is it? Let's see here. Let me do this real quick. Hold on. Is it better? Is it better now, or is there still buzzing? I don't know if this is working. A little bit, but I'd say go with it. Well, I can do this. We can try a couple things. Maybe that's better? Still a slight crackle. Run with it? Are you sure? Because I don't have to. Well. Okay. Hi, Angelic Mastermind. How are you? Okay, we're going to go with it. If it's still there, I apologize if there's still a small crackle. But yeah, so that's the thing, is I think that I would go back and talk about that. Good to see you, Angelic Mastermind. Welcome, welcome, welcome. We're doing viewer questions today. So if you have a question, exclamation mark, ask in your question, space in your question. And then, let's see, so we have Mr. Ovi says, does God play dice? And the answer is, I sure hope not. But probably. I would love to have a way where we can talk about the universe in a deterministic way. I think a lot of people would rather have that and just hope for something to come out of quantum mechanics. Maybe. So Meridian says, are you a PhD or post-PhD? I am a PhD student. God plays Pokemon coins. This is true. Many worlds is completely deterministic. I know, but many worlds is also not proven to be correct. Did Jax ask a question? Oh, no. I see. I want to answer. I'm going to answer Jax's question. I promise. I will answer Jax's question.
Such a
Stop.
Deterministic, dear Anubis.
Deterministic. What? What? People want determinism. I want determinism. Other people want determinism. Is it there? It's hard to see it happening right now, honestly. But it's not. It's not out of the cards. So am I a PhD or a post-PhD? I'm a PhD student. I study quantum field theory, high energy physics, and quantum computing. So really the overlap between high energy physics and quantum computing. Determinism is boring.
Nature is laughing at you with 99% probability.
Oh, get over it. I honestly, I would love for some sort of combination of probability and determinism. Like, what is it called? Not superdeterminism. I don't know. There's a bunch of small like subsets of words that I don't know what they mean. But yes, I am currently in my PhD. I'm in my third year. I've done 2.5 years of grad school. And I recently changed projects, which we're going to talk about from one of Jack's questions. People who want determinism drink warm water. I don't even know what to say about that. So Bernoulli principle. Phantom, if you would want to know what the Bernoulli principle is, can I explain it? I always think of Bernoulli's principle as the balloon in a car. Okay, so if you fill a balloon with helium in a car, okay, and you drive forward, you would expect the balloon with the helium in it to move backwards, because everything moves backwards, right? Everything accelerates backwards. But Bernoulli's principle basically tells us that lighter objects will always be pushed forward due to the forces of denser objects acting on lighter objects. So, if you fill a balloon with helium, helium is very, very light. It floats. Obviously, it's less dense than air, which is why it floats. Bernoulli's principle. So if you put a balloon in a car and drive forward, the balloon with helium in it will actually move forward in the car. Why? Well, because all of the air that's inside the car starts rushing towards, not all of the air, but the air starts rushing backwards, right? When it rushes backwards, there's a force as the air tries to get to the back. There's a force that's pushing the balloon forward to try to make room for that air that's coming to the backwards. So it's counterintuitive. You might say, hey, I'll put, if I put a helium balloon in a car and drive forward, then everything in the car will go backwards. But if it's lighter than the air, then it's going to go forward. So I would say Destin from Smarter Every Day has an excellent video on that. Very short, it's entertaining. Smarter Every Day, great video. Watch that. Bernoulli's principle. Next up is Jack. What are your thoughts on quantum computing? How long do you think until they're common? I actually think they're several decades away from being common. I would say in the next 20 years there will be one in a university if you have the money for it. Much like most of like microscopy and things like that nowadays. If you have a grant for it, you can get one in your computer. You can get one in the lab. I would say probably 20 years minimally, but I'm very uninformed. You might have different opinions, different ideas, but my opinion and my uninformed opinion is that 20 years, if you have funding, you can build one in a laboratory in any given university. I don't think they will be home usable, but maybe that's wrong. I don't think quantum computers will make sense to use at home. Maybe somebody who has a reason to do it at home will have one, but I don't see how it would be a thing, unless like your need. I don't know. In 2000, I'll give you a little bit of a time frame. In 2018, someone said 5 to 10 before they were usable computers to do stuff. In 2018, they said that. That seems to me like a reasonable timetable because they're an expert on the topic. 2018, they said 5 to 10, a usable quantum computer. It's a materials problem right now. We can't stop the qubits from decohering, meaning they keep dropping to their ground states, as opposed to like staying entangled and carrying out calculations. I don't know what Turing complete means, Tensor. Give me, what's Turing complete mean? I am sorry, I don't know. This is something that's talked about in the book, so I could look it up actually. Maybe I'll just do that. But yes, I don't know. So let's see. Cosmolano says, why is making a time operator in quantum mechanics such a problem if we have if we have a position operator. Because position we treat as a dimension and time we do not. That's my base answer. Time has to do with a process. Space doesn't have to do with the process. Space has to do with a location. If we were concerned about a location and time, then I think we could treat it like an operator. But we're not. We're concerned about the length of a process, which makes it complicated when you talk about time in quantum mechanics. In quantum field theory, I think you only recover it by using the time ordering operator. So why not just treat it as a dimension? You run into all sorts of issues. I don't know off the top of my head what the issue is, but Andrew Dodson has a video on it. Maybe somebody could link that. Andrew Dodson has a video on why quantum mechanics and general relativity don't mix. And I think it has something to do with time. I'm not sure, actually, now that I think about it. Maybe it doesn't. It's a very straightforward quantum mechanical answer. But I don't remember off the top of my head. Let's see. Basically, if you only use permutation operators, a quantum computer reduces to a reversible computer, which has already been shown to be Turing complete. There it is. For example, you can make a Turing machine with ideal billiard balls. So you can turn it into it. So Turing proved that certain computer paradigms can solve any problem. Turing machines implement these paradigms. Turing complete systems be used to implement Turing machines. Yeah, so his video is the best. Thank you for the thank you, NC. Was I supposed to mention teleportation now? They do under certain circumstances, but they don't in general. And those certain circumstances aren't proved yet. I was not paid. Yeah, check out the Dodson video. It's a very, very, very straightforward, simple explanation of what's going on and where we're at right now with understanding it. TLDR, quantum computer is Turing complete. There you go. Admiral is an expert on quantum computing and has answered and got me out of some hot water a couple times with these questions. I often don't know the answer to these questions and will refer you to someone who does. And Admiral Entropy makes himself available to answer these questions, which is fantastic. Jeffer says, play piano. Hey, Jeffer, good to see you. I know chords on pianos. I can formulate chords. Can I play chords on pianos? No. I can't play a combination of chords on piano. I can tell you where the keys are. I can put a chord together. I cannot play anything coherently or with fluidity. Look at that. We're going to hit Jax's questions right at 3:30. Fantastic. Let's do Jax's questions. Jax asked me a series of questions. I am through the queue. I've answered all of your questions or had asked for help. Who would win, Alien versus AI? I don't know. But Jax asked me a series of questions. Alien versus AI? Alien, because AIs don't do anything right now. That's funny, though. Who would take over? What if Alien is AI? Da-da-da! Who would take over us first? Probably aliens. So Jax asked a series of questions. Let me answer them. Excellent questions. So the first one is, for the noobs, what actually pushed you to start a Twitch for physics, and how has it changed since you started? So this is a wonderful question. So if you are a part of the Discord, I had a series of things that you guys could ask questions about, and one of them was content creation. So I'm really glad that she asked this question because content creation has been on my mind quite a lot lately. But I started the Twitch channel as a means to help people get questions answered during quarantine, right? Sort of like an open office hours. The problem is I've only ever taught intro physics as a TA for grad school, because I'm in grad school. And now I know intro physics quite well, so I can answer questions quite well. But then once the first day was, or 2 days or 3 days were done, hey Uncle Bill, good to see you, good to see you. But once the first few days were done, I had a small community, and you know, I was just like, so what should we do? Should we keep answering questions, or should we do something else? And it was Jax and NC specifically who were there at the time, and they just wanted to keep going and keep talking and learning about physics. So it kind of shifted after a few days to like, all right, let's talk about physics. And then it turned into, what do I want to do with the channel? What type of content do I want to do? And as you guys know, I think teaching is incredibly important. I think it's, I've said this phrase a bunch of times, and I'll say it again. The best tool that a physicist has for solving complicated problems is the next generation of physicists, right? And that's not to say that you should take advantage or abuse them. Instead, you should make them happy. Try your best to make sure that they can work efficiently, which oftentimes some older advisors think that means micromanaging and trying to run their lives, when in reality it just means being a support system and trying to help them ask important questions and get good answers for those important questions. And then, yeah, Rusa, exactly. So that was my idea, was how do I go about doing content that I think, A, is important for teaching rigor and actual physics, because there's a lot of videos on inspiration, and I don't, that's not me. I don't want to say that's not me, because I think that is me, but that's not what I wanted this channel to be. I wanted this channel to be about learning physics rigor and actually getting questions answered. And that might mean that we have a stream where people come and they don't have questions. So what do we do? So my idea was, well, I'm just going to start picking topics or asking you guys what topics you guys find interesting, and then we'll just start going over it together, kind of like a reading group, except, I present the information from the reading, and if you've done the reading or, haven't done the reading but just want to tag along, then you're welcome to. So instead, what we ended up doing was we started an 8 or 9 part lecture on path integration, and then we did a shorter one on general relativity, which I had to stop for another thing we'll talk about later on in this series of excellent questions. And then the building things happened. Jack says in another question, which is also pretty relevant to this one, why did you start building things? I can't remember what the first build stream was. The first build stream was the coupled pendulum. Okay, we started with a coupled pendulum. Now, a coupled pendulum has an excellent visual, and I saw it and I thought, hey, I could throw that together during a stream. So I did it. I just threw together a coupled pendulum. It was a mess. It was fun and it worked beautifully, but it was definitely a mess. And then Darla ate it. She didn't eat it, but she did tear it apart one day. I think it was like swinging, and she was like, "Ooh, a swinging ball," and then it was like, "Bah, bah, 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 bah," and it was gone. But yeah, so
Come here, Darla. People need you.
When the springtime comes back and the garage comes back, Darla will be back as well. But yeah, so the thing that's important to me about building streams is that, the inspiration comes from a lot of things. And it can come from having your face down in a book and working at it, but can also just come from tinkering around and finding out how the natural world works in a very disturbing and rugged way. Like anything from ripping apart a lighter and finding the piezoelectric crystal and then shocking yourself, to building a Tesla coil to learn about induction, and then what else did we build? I mean, the trebuchet was the second build. That was funny. But just learning about how it was different, like the different motions and the kinetics and the rotation and all of the inertia and things like that involved with it was just important to understand. But not just understand, but to see, and to see it come together and to work on it. So that's why I do building streams. I think they're important. That it's important to tinker with stuff and to figure out how things kind of work. And like I said, I just happen to do it in a very rugged and brute force kind of way. But I think it's important, and it's fun. It takes a break from the rigor and from the hard math and stuff, and gets down to some intro physics lessons and whatnot. So that was the motivation behind that. Jack's next question: when you were chefing, did you ever come across other guys who were at some point in the STEM field? They were generally art guys, yes, but they were all very fascinated and interested in science. I knew there was a couple people who were math majors at my university who were working at a local restaurant. But in my restaurant, there was not. Lots of interest in music, lots of interest in art, and lots of interest in science from a learner point of view, but not from a educational point of view. Boring math professor. Yes, they were math PhD students. There's I think 2 or 3 of them, and they were working at a local gastropub, while I worked at the local eclectic restaurant, and it was all downtown. And yeah, they were excellent cooks from what I heard. They were fantastic cooks as well. Yeah. But no, not scientists. No, just people interested in physics and interested in science and space. How many women are in your department? Do you work with? We had about 2 to 11 ratio of women to guys in our department. Just wondering what that ratio looked like in other places. In ours, it's probably around the same. I do want to mention one thing, though, and that is I have always found my university to be incredibly inclusive and diverse. I am very proud of my department, and I can say that with a clear conscience and wholeheartedly because I'm very proud of my department. They fight for the graduate students who are minorities, and they don't, and our graduate union especially does that. I am very proud of my university, and I think that they are always looking to be very diverse and inclusive. And like I said, I can't say that with an open, like without feeling like I'm telling a lie, because I really do think they are that way. But we do have the same ratio, yeah. And then it's a matter of encouraging women. I think the next generation of physicists will have a lot more women, and I'm looking forward to that because I think that's going to add a lot more diversity to the ideas that are in physics right now. Every graduate school has a graduate union, as far as I know. If they don't, it must be incredibly small. They had an interest in science. They were. That's probably true. So that excellent question. So Jack says, "What is your favorite frustrating part about teaching first years? Like, is there something they just can't understand?" No, I don't think there's anything that I'm I really don't think I'm frustrated with anything. I know there's a lot of students who get frustrated with their first years for a lot of reasons. And I don't know. Do I have any of my first years here? Is anybody in chat that I taught? I know Seth from earlier was a first year student of mine, who I had for 2 semesters. I think Bachman, I've only had you for the 2nd semester if I remember right. Maybe over the summer too, but I can't remember exactly. Yeah, I'm pretty sure. No, I must have only had Bachman for my 2nd semester. But yeah, I'm not frustrated. If anything, I think the only thing I'm frustrated by them is I wish that I wish they listened when I told them it's okay to get lower grades in this class. You took physics a while back, okay. When you start to take physics in freshman year, it can be a really big wake-up call because on your first test you might get in the low 40s or 30s or 20s and still be okay for the entire semester. And I think that's hard to kind of like convey to my students, like that it's okay to not do well in the beginning of this class, and it's okay to continue to only do like 40s and 50s, and you're still gonna pass, and it's all right. But a lot of them take it very personally, and to me it's hard for me because I see them taking it personally, and I don't want them to because I know in the end it's just not gonna matter. But that's hard when teaching first years. Is knowing that they're going to take it personally when they do poorly, and they shouldn't, because they're doing just fine. My name is Seth. I'm your first year. I know you because I watched you stream before, and you are not the Seth that I'm referring to. I don't think you were in my class. I don't think you were. Are you even in the States, Cosmoano? I think you're in the States, but I don't remember where. My name's Seth. I'm your first year. But yeah, so that's my most frustrating thing with them is, yeah, I really do wish, yeah. What's the conversation? I don't know if Yale managed to get unionized. A lot of the Ivy League schools still don't have a grad. Oh, I didn't know that. Can we still ask questions about quantum? Oh, yeah, no, Cyber. Go ahead. Ask away. We still have 20 minutes left, at least. And we only have a few questions left. So if you have a question about quantum computing, ask away. Excellent questions today. I am floored by the amount of great questions today. There's only one few things I wanted to talk about with my own stuff too. And I'll get into that in a second. Hi, Max. Good to see ya. Good to see ya. Okay, there you go, Boulder. Okay, cool. Do you know Alex Flornay? Hey, Stanzel. Good to see you too. Is he at your school, or is he in a different place in Colorado?
Thank you, I agree, my questions were brilliant.
Oh no. But yeah, that's my biggest frustration, is that I wish they would understand that their ability to learn physics and their ability to perform at a high in the 80s and 90s are not the same thing. And no matter how often I say that, I still see them taking it personally, and it's a big bummer. Because they're beating themselves up over something that won't matter, and it feels bad. Okay, so this is a heavier one. So after changing your supervisor, and this is the last one of Jax's questions. But if you guys don't know, in October, my advisor suddenly had to retire. My previous advisor suddenly had to retire for health reasons. And I ended up having to take a break from streaming for about a month and kind of figure out my life in a very short period of time. Because before then, I was just vibing. I was researching. I was doing stream. I had walked away from the restaurant industry 2 months prior, and I had to figure stuff out quickly, like whether or not I was going to finish my PhD or master out, which mastering out is in no way a bad option at all. A lot of thought went into that. It was very, very difficult.
Reasons include too much, Eric?
It was very difficult, period. And you guys know that was like a rough month in general for me. And a lot of you guys went through that with me, so I appreciate that very much. But let's hear Jack's question. So after changing your supervisor last year and having to adjust your research because of it, how is the new topic going? Is it similar to what you were doing before? Yes, it's very, very similar to what I was doing before. Had I continued on with my previous project, they would have started to diverge quite a bit. I would have started getting into the astrophysics and cosmology aspects, because it was dark matter mainly. But I didn't get there, so it was all mostly quantum field theory formalism and just about particle physics, like a lot about particle physics. So to go into quantum computing and still be allowed to work on quantum field theory formalism, and in this way, I was able to work on time. And like my project might not finish the way it is right now. It might not finish with a focus on time, but right now it's focused on time inside quantum computers. And I'm using quantum field theory formalism to understand it. And that is different than where I would have gone had I stayed in my current PhD. I would have started the astrophysics and cosmology part of it. My new advisor has been fantastic. He has... I was very nervous about having a new advisor because I looked up to my old advisor so much. He was an absolutely wonderful mentor and meant the world to me. But my new advisor has been fantastic as well. And it's different working in a group. I am getting the dynamic, I think, but there's a lot more accountability amongst group mates than I'm used to because I never had a group mate. So that's different, but it's good. It's healthy, I think. Overall, I think it's going to be perfectly fine. I don't think I'm lost too much time. I think had I gone much farther, it might have started to get to a problem, which maybe my old mentor had like the foresight to see that, he wasn't doing well and that it could be really bad in the future if I continued. What's a group? So yeah, that was... It's been a trip, but it's a good one. I think so. Okay, so, but that's all of Jack's questions. Excellent questions. Thank you, Jack, so much for asking those. So let me say a few things about what I have to say. I did have a little bit of a prepared thing, the master of time. Let me say a few words about the things that I wanted to say, and then I'll answer the rest of the questions. There's still 4 more questions in queue. Thank you guys for asking so many wonderful questions. But here we go. one of the things that's been getting me in a funk lately, a physics funk, is that I had a really big idea. And I started to think about this, okay? And people on here are, have had big ideas and presented them to me and whatnot. When I say big idea, I mean a really, really big idea. And I wanted to talk about 4 things that it means when you have a really big idea, okay? And the fact that, like, this gives me a lot of, anxiety or self-doubt or something like that is just a me thing, okay? But I would say that it's healthy to have these thoughts even if it makes you feel uncomfortable. Now, this is me as a researcher, as someone who has been researching for 5 years under supervision of researchers, not by myself, but under supervision of other researchers. And these are things I've noticed about what happens when you have a big idea. Okay? And this is the order of the most probable outcome. Okay? So what happens if I have a big research idea? Okay? There's 4, like I said, 4 possible outcomes that I work through. And I work through these pretty much every time in one way or another before I decide on whether or not to stick with it. And the first one that's most probable is your big idea is wrong. And that's probably the hardest thing to think about. So firstly, you have a really big idea. The universe works a certain way. Everything is a certain way. Blah, blah, blah. Whatever, big idea. The first probability and the most likely is it's just flat out wrong. Okay? And that's something that you should really weigh considerably. So spend a lot of time thinking about your big idea. Think about if it's wrong or not. This is all before the work actually starts. This is just when your idea first starts. Okay? And when I say think about this, it's really like as you're starting your work. Because I'm now working on calculations and things like that for my big idea that might, but ultimately I'm going into it knowing that it might just be wrong. And oftentimes I've had ideas happen where actually every single time I've had big ideas, it's either option 1 or 2. Option 2 is it's known and addressed already in the literature, whether or not it's right or wrong. So whether it's right and it's highly addressed in the literature or barely addressed in the literature, it's just addressed in the literature, or it's known and it's right and it's highly addressed in the literature, or it's wrong. I don't remember which one I already said, but it's either right or wrong and it's already addressed in the literature. So you have to look very heavily through literature when you're researching. It's natural to do that because your big idea depends on it. Okay? So the first and most likely outcome is it's wrong. The second most, and you'll reason your way through that eventually. The second most likely outcome is it's already known. Someone's already done it. Okay? And so the third one is your big idea is correct, but it's going to take many, many years to develop. Okay? When I'm talking about big idea, I'm talking about a big idea. I'm not talking about working through another step, solving another equation, getting a diagram of interest. I'm talking about Higgs boson level idea, things like that, really, really big ideas. Because people get them. Don't get me wrong. If you met a physicist who doesn't have a big idea, then I would question, that physicist. Because everybody thinks in really big ideas. It's just the majority of physicists will recognize that it's wrong right away. So third, it's correct, but it's going to take many years to develop. So where do you start? You just start developing it and hope that you don't have problems. And the best bet you can have is to publish smaller results along the way so that it continues, so you continue to work on it. And thirdly, it's correct and it's accessible, or fourthly, it's correct and accessible. This one is very, very rare. I don't know of many physicists, maybe Einstein, who's had this happen to him. Even Dirac, I would say, with his Dirac equation, is probably more about a 3, where he developed the Dirac equation, and he had to spend a lot of times developing it before they could actually find it with the Dirac equation.
Did you finish answering Dr. Jax's question?
I did. I answered all of Jax's questions. I did. Thank you. Thank you for checking up on me. But yes, that's my idea, is that those are the 4 things that you should work through when you have big ideas. You should A, try to reason with yourself that it's wrong. That's the first thing. 2, you should try to find it in the literature. 3, you should start to develop the formalism and recognize that it could take many, many, many years and start to look for smaller projects in the middle of it. My professor, my old mentor, the mentor that I was with previously, specifically told me, when you're going through research ideas, write down a bunch of side projects. The first one is it's wrong. Is that what the question is? The first thing that's probably, oh, the fourth thing, it's correct and it's accessible. And that's it's very, very, very unlikely that your big idea is correct and accessible off the get-go. It's obviously the most optimistic, but it's usually, in almost every situation I can think of that's not a historical tale, it's the most unlikely to occur. And we all know this, and that's why it's still good to think in big ideas. Don't get me wrong. It's still very good to think in big ideas, but recognize that it's probably almost always wrong. Yeah, and that's not to discourage you, because this is literally how life as a researcher works. You go through ideas, and every once in a while you have a really big idea that's really cool and inspiring. But cool and inspiring does not make it right. You know what I'm saying? Like, that's the biggest thing you should recognize when you have a big idea, is that cool and inspiring does not make it right. So yeah, my old mentor always said, if you have an idea, like a big idea, that was the fourth one, was that it's correct and accessible. I'll go over them again in a second. But he said that if you have, I don't mean to be a downer Debbie. It's not that I mean to be a downer Debbie. I'm saying this from a very practical way. And physicists handle it every different way. You know, like all physicists handle it a different way. Some physicists can handle it without even blinking an eye. They'll be like, I had this idea, it's probably wrong, I'm moving on. And they don't even care. And other physicists like me might really try to work a little bit harder at it and try to salvage anything. Now, this big idea I've had, I've just barely started. And I'm in the process of scouring literature. You know what I mean? Like, I haven't been able to reason why it's wrong, so I'm scouring literature. And I still might just find out that it's flat out wrong. Like, that's a possibility. But yeah, but big ideas they often just don't lead anywhere. And it's important to remember that. But my mentor, the thing I'm trying to say is my mentor, when I would bring ideas to him, be like, what about this? How does this work? What about this? How does this work? He'd be like, write these things down as a side project. I won't be talking about my big idea, because if it's obviously wrong, I want to be the one to find that out. I don't want to be told that it's obviously wrong by Twitch chat. I think that would be a rough experience for me. Yeah, it is exciting. But yeah, when I do have, and I also try not to get too excited about them, because I've had a lot of them, and like I said, every single one I've had in the past, it turns out to be wrong, and I turn out to recognize it within the first few days. But it is always this experience where it's hard to get through the first few ideas.
Not even wrong is worse.
Not even wrong is worse. Yeah. But yeah, so the idea is just, if I am wrong, I want to find out on my own, and I could find out later today just perusing, archive or like Stack Exchange or anything that is already very well known that this idea is wrong, and then I just move on, and that's what you do. You always just move on. But yeah, my mentor would always say, if you have these ideas, write down subsets of ideas for later projects. So if you have ideas like, if you have ideas for like thinking about things in one way, write that down. In another way, write that down. In another way, write that down. So even if you have, bye Jack, it was good to see you. Take care. Good luck with school starting up again if I don't see you before it starts. Yeah, and if you write down small projects that you can work on in the future, because any time something could come up, and you might be like, hey, I've thought about this before, let me go back and look in my notes or something like that. Or if you are just like, I need something to research, go look in your book of ideas. Maybe something between the time that you had the idea and the current time, maybe you've developed more thoughts and can take one of these old ideas that might not have been the greatest idea and turn it into a great idea. Like, that's something too. So there's a lot of things. It's not always about having right ideas all the time. Most of the time, it's about having wrong ideas. But you have enough wrong ideas, every once in a while you might hit lucky and get a good idea. You know what I'm saying? So, and then, wouldn't it be productive to just ask? Yeah, but there's a certain sense of, if I ask and I find, and I don't have enough, I think it'd be better if I find out on my own. It's much like reading a textbook and finding the answers out to the problems on your own. It's better to work through these things on your own so you actually can experience the working throughing of the problem. Not necessarily just getting the answer, but working through. Now, if I have a question that's smaller, I'm just going to ask my advisor. You know what I'm saying? Like, if I have a question like, hey, this is thing I've been struggling with, I'm just going to ask my advisor. If he knows the answer, then great. If he doesn't know the answer, I'm going to start looking in the literature and stuff. If I have a really big idea, I have to work through it for a while. That way I know whether or not it's even worth asking to my advisor, because I might have to go down the path of figuring out all of the steps to get there on my own. And then along the way, I might find an obvious step that I was missing, and my personal opinion is that if I find that step that I'm missing on my own, I'm much likelier to remember it the next time I have ideas like this. That's just how I see viewing learning. But like I said, it's just a small question that takes like one step to get there. Like, you know, like there's things that he does in magnets that I have no idea about, and like I'm just kind of curious about something about a magnet. I might just ask him that, just because. I'm not gonna find it in literature because I don't even know where to look. I can be told, but it's like I said, it's for me. Like, okay, how can you even say what you were told makes sense if you don't understand it? I don't know. I might feel more be compelled to be unsatisfied with an answer and just move on. Which you can be very very much. I guess it just depends on my mood. I don't know. Like I said, looking through things step by step seems to me like it's a better process than getting to the answer and not experiencing the steps on my own. No. I don't see you as policing. I realize that you're asking me how I learn, and like part of this stream is, and I even have a Discord channel where it says learning. Like learning is never taught. So when you learn, you have to figure out how to learn on your own. And part of this ideas. I read John's question. Part of this stream is, you know, to teach each other how we all learn, and to it's a grab bag. Like, if something that I do might work for me and not work for you, and that's fine. And that's the nature of the beast. Okay, so let's get through these questions. I have a couple more questions. Wouldn't it be more like, this is Cosmolano, wouldn't it be more likely for aliens to be AI, since AI would figure out interstellar travel faster than biological intelligence? I don't know anything about AI. I don't know how. I don't know enough about the learning of AI. To me, it's more of a science fiction thing right now. I know about like the Go documentary that someone shared. Oh, in my Discord, go watch the Go documentary that someone shared. Absolutely fantastic. I don't know if that person's here right now or not, but that Go documentary was absolutely fantastic. Really, really good. An AI learned how to play Go and learned rules or moves that we thought would be subsequently bad. However, you know, later on, it turned out that move was fantastic. Yeah, that's true. Robots could handle space better than intelligent meatbags. So I guess the survivability in those terms, then yes, survivability. They would be lighter and could handle space. Any AI life form would also have an easier form of traveling, yeah. They wouldn't have to worry about dying in space. So there's always that. You saw an AI learn how to play Super Mario World. That's pretty cool, too. All right, let's keep pushing through these. John says, when you connect two differently inflated balloons with a hose, which one will the air move into? If they're evenly connected, it will go evenly. If they're connected in an uneven fashion, it will go unevenly. A good way to think about this is the velocity of the fluid times the area is equal to the velocity of the fluid times another area. So, smaller area, higher velocity. Which makes sense if you squeeze something. So if they're the same area, same velocity, it's going to go the same direction. Now, there's all sorts of the things you can pedal into that. But as long as in introductory physics, same area, same velocity, same filling. Two differently inflated balloons. So if they're differently inflated, I don't think they're going to be equal. So I think that the goal will be try to equalize it. Because you'll have some unequal force coming back at you. That's how pressure works. Pressure is going to be average force on every wall. So if there's more force on the one wall that is the entry to the hose, then you're going to have more force coming out. So I imagine it will probably fill less quickly and try to equalize. But I don't know any of the math off the top of my head for that. Haney, when you work at university, do you write books or just get grants? So you get paid a faculty staff, or faculty paycheck. So you get paid to be faculty. Kingdom Saver, I can, actually, but I have a few questions before that one that I'm going to get to, and then I'll answer that question. I am so surprised you guys had so many wonderful questions today. Thank you so much. This has really, really made my day. I was very nervous that I wouldn't be able to, I was really nervous that I wouldn't be able to help people today just because I was worried that people wouldn't be interested.
You are
But
welcome.
you've had wonderful, wonderful questions. So yeah, you get a paycheck for being a teacher, for being a professor. You have professorial responsibilities and department responsibilities that come with that. And then your research, you'll have grants to pay for your research needs. Like if you want graduate students, if you're an experimentalist, you need a lot of money because you have experiments to run. But if you're a theorist, you just have to pay for graduate students or materials like computers if you need some computations run. I know of a couple theorists who have some really, really heavy, high-powered machines to run computations. But yeah, it's for grants is mostly for research. You get paid to be a professor. And then there's some tricky stuff with that. Like schools get part of your research money. So schools aren't going to give you a big grant, or schools aren't going to give you a tenure if you're not making any grant money because they want money from the grants as well. It's like, blah, blah. Tenure is good. Tenure is, there's got to be a better way. I don't know. If there is one, I don't know, and I'm certainly not an expert, so I should probably just stop talking about it. So Captain Frantic, good to see you again, by the way. I see you have a couple questions because you missed the part. So let me grab this. My friend is convinced that photons do not move. Everything else does. What can you say about this? Photons obviously move. We have a speed of light, right? And speed of light as a photon, photons move at the speed of light. They move. 3 times 10 to the 8 meters per second. Now, if you're in the photon rest frame, that's different. That's very complicated, and we have a pole there, which means we have an infinity there, and I don't know if it even makes sense to ask the question, what does a photon see? But in our rest frame, or in our frame of reference at all, anything with mass is frame of reference, light definitely moves. Photons definitely move. Yeah. Is that good? If anyone asks if it doesn't move, if anyone tries to tell you that photons don't move, just tell them the speed of light, that they move exactly 3 times 10 to the 8th meters for every second. that is movement in the most purest form. So in classical computers, there's a concept of atomic operations. Atomic compare and swap, for instance. Can you do those in quantum computers? That's not... Okay, so the answer is yes. There is a swap operation. Hello, Julie Strater. Welcome, welcome. Hello, everyone, from Julie Strater's channel. How are you? How was your stream, Julie? Hello, everyone. Castellano. Yes, it's technically not that high. Hey, Quim. Hello, McSen. War Darkness. Hello, hello. All right, so my name is Air. Welcome, everybody, from the raid. I hope you had a good stream, Julie. What did you do on your stream today? Thank you for the shout-out, NC. Are you prepared for 198 people? Sure. Everybody's welcome. Let's just keep going, then. I mean, that's awesome. Let's ask some questions. If you have questions, you can do ! Ask space and then your question, and then I'm glad to answer it. My name is Eric. I'm a particle physics PhD student studying the overlap between high-energy physics and quantum computing. So I like to take questions on... I actually study specifically in that area of overlap. I study time. So we are in my office at school where I work, yeah. So I don't know the E8 theory of everything, Death Priest, unfortunately. I've heard of it, but I don't know anything about it. I've only heard of it from surface level. I don't study too much theories of everything, though. Yeah, not my forte. I'm just interested in time, so that's where I spend most of my time working. It's quantum field theory formalism in quantum computing, trying to understand time. Julie says, hi, it was nice. I just finished the basic course on C++. My first programming language is going to learn some Unity now. That's awesome, Julie. I don't know anything about coding. Unfortunately, I'm a pencil and paper theorist. I have my head in books all the time. I know some Mathematica and some Python, but very, very little. If anyone asks me C#, oh, sorry, I don't know. I don't see. And this is what I get. I get it. C#. I'm gonna read a book. And I managed to convey how much I know about computing right there. But anyways, thank you so much for the raid and good to see you. Let me get to some of these questions. We're gonna prioritize Julie because if you raid my channel, I'm gonna give you priority to asking questions. Julie asked, "Where do I learn cool physics basics?"
Okay, sir.
Basics in fun, interactive way, so that I can stream learning it. Where's a good one? Khan Academy is a great resource for learning basics in physics. As far as YouTube channels and stuff goes, I personally ask for permission to show them, and everybody is always, save like 1 or 2 channels, everybody's always willing to like let me broadcast their content straight to Twitch. So I would say if you find something that you like, reach out to them. Khan Academy, 3 Blue 1 Brown, Grant Anderson's amazing. I would be surprised if he said no. He's a really, really amazing human being. Brilliant. I asked them, okay, yeah, I would check Khan Academy. I would check 3 Blue 1 Brown. Which does math stuff, but it's very related to physics, and he also does a lot of physics stuff. I would check Minute Physics. Minute Physics is brilliant. Oh, man. So Castellano wants me to prioritize his questions. Susskind has lectures online, but you'd have to go through the university. Stanford University is where they're all from. And I don't think it would be a big, I don't know. Like I said, everybody I've always asked has been really, really thoughtful. And like I've asked like PBS Spacetime, Sean Carroll. I've asked, who else have I heard back from? The people at Fermi Labs, Sun Games, Tigabyte, Demo Scene, and Romazed. Thank you so much for the follow. Welcome to the channel. Andrew Dodson's really good. I've asked Dodson. Dodson gave me permissions to watch his videos, but they're a little bit higher than basics, I would imagine. He does a couple basics videos, but it's not like a basics series. Numberphile are great too. Numberphile is very, very good. Yeah. You talk the real Sean Carroll? Yeah, he responds to emails. He tries to respond to emails if you ask him questions like that. If you just send him like theories of everything, he's probably not going to respond. But I've asked him questions. I've asked him if I could use his notes that are on archive and everything like that to teach on the stream, and he responded in a few days saying that I was more than welcome to use any of his materials on YouTube and stuff like that. But yeah, he was very, very kind and shared all of those resources with us. Let's see where Cosmolano's at, because I told him I'd prioritize his question. So Cosmolano says, if big ideas don't lead anywhere, what should we opt for instead? And I don't think that they don't lead anywhere. I definitely don't think they lead they don't. I do think that they can lead to good things. Oftentimes what I think is that if you have a big idea, you should approach it very conservatively and notice that the ideas that you have are probably wrong. I don't know. What's Tyrion even talking about? Oh, jeez, Tyrion. But anyways, yeah, so it's not that I think that you shouldn't pursue big ideas. I do. I think you should pursue them in the mindset of, how do I prove this wrong? And if you can't prove it wrong, then start to work through the other options on the list. So like I always spend time trying, if I have a big idea, I immediately try to prove it wrong right away with my own thoughts. Because there's egocentric bias that's going to go into any idea you have. And this egocentric biasness is dangerous for researchers. Admiral. Yeah, so egocentric bias is very dangerous in research. And if you go into a project and you think, hey, your ideas are beautiful, they're consistent, they're right, and you don't challenge any of them, I think it's very dangerous. And it's only dangerous because it could be a time sink when you could actually realize that the ideas were flawed at the very get-go. So that's just, and like I said, this is only my way of doing things. So I don't want anybody to be like, this is the way. This is not, I'm not no Mandalorian race of beings here. This is just how I like to view my problems when I get a problem to work on. But yeah. So I always approach it when I have a big idea that's not just like a small, like, hey, throw a calculation together really quick. When I have a really, really big idea, my first goal is to try to prove it wrong. And if I can't prove it wrong, I start to investigate much deeper. If you are new to the channel, usually we do more rigorous physics stuff. On Wednesdays, I have an electricity and magnetism series I do where we follow through Griffiths. We're on part 3 of that. On Friday, I have a quantum computing series where we're going over quantum computing, where I follow Nielsen and Chang. I put all of my VODs on YouTube. So here's I'll just put all my socials in there, and the YouTube's in there. And then the Discord's open to ask questions if you have any questions about physics. I have lots of professional physicists in my Discord who are open to answering questions and would love to answer questions. So feel free to ask them. To ask any question in Discord, and if I don't know the answer, there's a good chance that someone does. So let's see, what else do we have in the old grad? Oh yeah, and then on Sundays I do building streams. I forgot to mention that part. Usually on Sundays I'm building physics demos. I have my hands on a project. We're doing something. Next up, we're building a hand-powered Van de Graaff machine. Thank you for the follow, Julie, and thank you for the raid so much. Yeah, on Sundays, I try to do more introductory physics, have my hands on building some sort of physics demo. They're physics building streams. Next week, we're starting a hand-powered Van de Graaff generator. And then we'll talk about the history of the Van de Graaff generator. We'll talk about the science behind the Van de Graaff generator. And hopefully, we'll build one. And maybe I'll get shocked. Might be a very shocking experience. The Skeptical Potato, thank you for the follow. Really appreciate that. Okay, so Cyber Cobalt Ethan says, so in classical operators, oh, I already got that one. Okay, cool. Let's move on. Angelic Mastermind, not a physics question, but I saw something about Discord channel. Is that open to the public? Oh yeah, absolutely open to the public. It's in the, oh look at Stream Elements just put it up too. Wait, did I miss it? Oh, you missed it. Yeah, so we do have a swap gate. Oh, maybe I got rated. Maybe that was, yeah. So we do have a swap gate in quantum computing. It is the X Pauli matrix. So if you know Pauli matrices from quantum mechanics, it's the X one. It's 0, 1, 1, 0, and it basically just swaps the 2 qubits in the state. It is not the same as the classical swap, but it does a very similar thing. Is it a conditional swap, though? No. I don't think it's conditional swap. It is a... I don't know if there's conditional stuff. I don't think there's conditional gates in quantum computing. I might have to get back to you. Goofy Lagrangian, you are coming up. I do see your question down there. I think you're 5 on the list. So yeah, I think that's the C naught is conditional. Controlled not? Yeah, I guess controlled would be conditional. So when you ask me questions that have a lot to do with classical computers, I start to not know the answer. So I guess control would be conditional. I was thinking more of like XOR. I don't even know if you say XOR. That's just how I pronounce it. I have no idea. A Pascal. Thank you for the follow. Welcome. Red Chair Bird Hat. Welcome to the channel. Thank you for the follow. Yeah, I had to think about it for a second. It is XOR? But yeah, like, so XOR is not allowed, and that's kind of what I was thinking. But I guess conditional and control would be the same thing. So yeah, there's conditional, so there's conditional not, conditional swap. Sukaza, thank you so much for the gifted sub to Julie. I appreciate that. Thank you, thank you, thank you. Now Julie has access to the pony emotes, our beloved pony. Our beloved pony. Okay, so, yeah, so Angelic Mastermind asked if I had Discord. Absolutely open to the public. Absolutely join, ask questions. Lots of brilliant minds in there. So Death Priest asked you, what do you think of E8 theory? Again, I don't really know E8 theory. I will tell you this, Death Priest. I don't want to give you like a dead answer, so let me tell you this. Theories of everything. Theories of and I think E8 theory is a referral to a theory of everything. Theories of everything, I believe in academic freedom and freedom of ideas and thoughts. There's some caveats to that. Like, I want people to study what they want. But I also recognize that that's not how reality works. In that, if you want to study what you want, you have to give something too. And oftentimes, it's giving up financial freedoms. Right? Like, that's the reality of it. Like, if you want to study what you want, you have to give up the ability to get government grants. In some situations. Oftentimes, studying what you want means you can't get government grants or whatever. But that doesn't necessarily mean you won't get funding. That might mean you just have to try a lot harder to get funding, or it might mean you won't get funding. But these people who are coming out with theories of everything, like, they don't need funding. Like, the ones that are big right now are like Weinstein, Wolfram, the one guy who has that institute in Hawaii. The name slips my mind. But all these things are like, they don't need funding, so they're legit to study theories of everything. But like, for a lot of people, like, funding security is really important. So like, they might have to give up the idea of studying something like quantum gravity or something. No, not you know. So yeah, so it might be like it's a give and take. I like the idea of academic freedom. I like that people study string theory and loop quantum gravity and these theories of everything. I like all of that. But I also recognize that the government is not going to be able to fund everything, and they're going to have other interests in mind. Yeah, Wolfram doesn't need a grant. He's okay. What? I say Wolfram and 8W, or EW, E8, whatever. Yeah. Anyways, but that's all I'll say about those. I like academic freedom. I like freedom of ideas. I recognize it's not a reasonable thing to get even grant funding, and that if you want to study what you really want to study, that's going to come at a cost, unless you can convince other people to fund you. And there might be a guy who studies like the most obscure thing ever, and is just really good at convincing people to pay him. That's my goal. So the guys in the Big Bang Theory were right about what? What was it? I don't have fun bit things, but now I think I'm gonna have to. Sukaza, thank you so much. This is my old laptop running the way it does. I'm sorry the alert was less than satisfying. But Coffee Grant, thank you very much for the 6 bits. I really appreciate that. I really, really do. Thank you. Fund my coffee. That's what theorists need. Is we need pens and paper and coffee. And then Goofy Lagrangian says, what exactly is quantum in quantum machine learning frameworks? What is all the hype about? So in AI in general, you want a process to look for certain things. So you set your machine up, and this is just, I'm not a machine learning expert. I don't really know. This is just how I understand it. If anybody in chat knows more, please share your information. There's already been one time where I said the wrong thing and my chat corrected me. Don't ever hesitate to do that. That's 100% good. But yeah, so in machine learning, you put in a bunch of parameters. The computer is supposed to recognize when a certain task hits those parameters just right. you funnel that information back in and adjust so that when you go through, you hit the right you hit better parameters, you cycle that information back in, you go through the parameters. So machine learning in quantum computing kind of works the same way. You set up a Lagrangian where as you work your way through the system, you're looking for certain parameters to pull out. The difference being is that you can't funnel information back into a quantum computer. Quantum computers have to go linearly. They have to move the information from one side to the other. And you can't always know all of the information on what's happening inside. Like, there's actual limits to how much you can know about the quantum information. We call it, like, certain parts of the quantum computer are a black box of information. Like, you cannot access information inside of that. And then you make a measurement, and all that information is basically like, it wasn't there and gone. The best way to think about it is it was never really there, even though you are utilizing it. And if you look through books like this, you know, like, they go over kind of in depth about how it's just like quantum, like, information. So yeah. So let me see what Strawberry says here. So they've experimentally confirmed anyons, right? I don't know. I wanted to say I knew that one, but I don't. I was under the impression that anion exists as a condensed matter, product. But I don't know. So yeah, so that's what the quantum is, that when you send it in the information to the black box, you can still manipulate that information even though you can't ever access it. And the idea is to access it in just the right way so that it produces the right parameters and you can continue to make your way through the linear system. Maybe even set it up so that you can set up repetitions of quantum gates and then focus really heavily on getting those parameters through. The big difference between quantum computer and classical computing in this situation is that in classical computing, you can't spread it out into like this ginormous phase space of like 2 to the 500 different, iterations of information. Whereas in quantum computing, you can. There's really nothing stopping you. If you have your phase space, or your amount of states, goes 2 to the n for n qubits. So if you have 500 qubits, which is not impossible to think is going to be done in 50 years. It's not possible to think it's going to be done in 25 years, in my opinion. That's not possible at all. Fit 500 qubits, right? That's 2 to the 500 states. That's more atoms than the observable universe. You can't do that in a classical computer. So the idea is to spread it out, to be able to entangle over all of those pieces of information, and then run it through and grab the parameters that you want, and then move into the next stage and grab and hone down those parameters, move to the next stage, hold down, move down the next stage, hold down, and eventually get something in a very linear fashion to have a good idea. Again, in machine learning, you usually don't need to look back unless you were in a learning phase. Okay, so that makes sense. So maybe you don't even need to loop it back. You can just keep running more linearly too. I guess I don't know enough about machine learning, but that's how I understand it, and I hope that's helpful. I'm not 100% sure how helpful that is. But yeah, that's what's quantum about it, is you're allowed to store information as entangled states. So you can take that information of 500 qubits, which is totally reasonable, and spread it out to 2 to the 500 pieces of quantum information that you can manipulate but never really access. A BSD guy says hyphen. Okay, so Julie says, I'd like to eventually make games that inspire people to try to understand the world on the fundamental level. So any physicist recommendation of what concepts you would want to see explained in a game for a wider audience? I would really like to see some ideas of quantum mechanics brought to the public in a game form. And the first thing that I can think of is quantum chess. Outside of the quantum realm, if there was something more down to earth, I would love this, or more, like maybe we'll say an earlier stage in the physics learning state career, I would say something with frames of reference. Frames of reference is really cool. So like you could have a frame of reference in a rotating body is Quantum chess is your game? I streamed it the other day. I don't know if you know. I'm in the Discord. I recognize the name now. I streamed it a little while ago, but there was no matchmaking, and I couldn't play a game against anybody. But we did it like a few weeks ago on a Sunday. I don't know how long ago. It must have been like 4 weeks ago now. We went over how it worked and talked about quantum mechanics and like what is a state, a quantum state, and how things could go. You just added matchmaking to the test server. I would love to stream it again if you're okay with that. I would love to do that. And then so we went over like what is a quantum state, and then we talked about how the game worked, and how it exists as superpositions, and how this would make sense from a probabilistic point of view and everything like that. So that's what we talked about, and then we actually tried to play it. We went over all the rules. I set up a couple scenarios and played through it a little bit, and then I went to play a game on matchmaking and realized there wasn't matchmaking. But it's like everyone knew it was a game in its early alpha, or it's in its alpha stages. So that was nobody, it was to be expected. So it's but now I'm looking forward to the matchmaking for sure. I'd love to stream it, definitely. But yeah, I would love to see frames of reference, Julie. That'd be a really cool thing. So like I said, if you're like, so one thing I like to talk about in my intro physics class is vectors. Because vectors are like a weird thing. Like you can do all sorts of vector analysis or different vector analysis by talking about frames of reference. Because everything is like with respect to. And people in intro physics in college don't know what with respect to means. So if you're talking about one ship versus another ship, how is this ship moving in vectors with respect to this ship? People like automatically want to talk about vector addition of a frame of reference from outside the ships instead of being put on one of the ships. And see, what were you referring to? Diffusion, entropy, and the tendency for nature to be as homogeneous as possible? I missed it. I'm sorry if I'm missing some things in chat, everybody. Let's go a little bit longer. Because I'll ask, do theorists really still use just pen and paper because that's a relief? Yeah. They do. Like I said, I am a subset of a small group of physicists that use just pencil and paper. You can find projects with just pencil and paper. What's that game? Sorry, I'll get back to the question in a second. What's that game where there's the perspective? I know if you're familiar with Cog Psych Prof, he plays it on his channel. A little shout out to Cog Psych Prof. I can't type apparently. I don't even know where that went. Can someone shout out Cog Psych Prof? But yeah, it's Superluminal. Superluminal, yeah. Okay, so Superluminal is a similar game to that, where you can, and it's, I don't know, that might be like a reference, a point to start from or something like that. But saying something that was certain about reference frames would be really cool. And that's like something that was kind of touching it, but it'd be cool to see something more like, and I don't know, I haven't played the game, but I've watched Coxsite play it a couple times. But something that would be kind of cool would be like motion, where reference frames in motion matter. But Superluminal is more about perspective, I guess. But either way. I don't know, that's kind of what I just thought of. Yeah, but I use pencil and paper and just bury myself in books. There's people who will tell you that to be a successful scientist, you need to code. I don't necessarily think that's true, but I think that that's the general consensus for the general crowd. And finding, again, it's like one of those things where, like, if you want to not code, like, you might have to, be willing to make a sacrifice in another arena, whatever that may be. But for me, I've always been lucky enough to not really necessarily need it. Maybe you'll have to do all the work to find someone who will code for you for all your papers, but I don't know. It's hard to say. But yeah, no, I don't code. Dead Baby Seal. Hi, it's good to see you, by the way. Do you have a favorite aha moment when something finally clicked when you were studying or thinking about something? Yes. Path integration. Probably about my 8th time through path integration, I realized that it's just probabilities. That they're just a bunch of probabilities, and the path that you take is associated with the probability, and configuration space has nothing to do with the current path of a particle. And it was just, I was sitting there and I was working at it, and finally one day I was just like, wait a second. Each path is just a probability. It's just a probability that a certain particle is taking a certain path. That's all. Like, and I moved on, and it was beautiful. And it was, as a computer scientist, you kind of do need to know what it's all about. I will be learning some coding, probably. I don't want to, but I will. They're amplitudes. Yeah, amplitudes, probabilities, same thing. Yeah, it's just like that moment when it all kind of makes sense, when all of like the weird like woohoo that people kind of spout off about particle being all paths at once, even though that's not what it means, and like all this other stuff, like all this stuff, the woo, kind of all just sort of like collapses into like a logical understanding. It's like it's one of the beauties of studying. Bachman says, do I think quantum computing will become as approachable as classical computational science once it's better understood, or is it inseparable from PhD physics topics? It is not inseparable. It's not now. Bachman, I think you should follow on Twitter. Oh, I always forget his name. I think it's Deepak Prasad, maybe. I have to look him up. He's not a PhD. As far as I remember, he's not a PhD. He started as an engineer. He liked physics. He went into quantum computing as a CEO of a quantum computing company. He's a brilliant, brilliant individual. I don't think he has a PhD, and he's already working in quantum computing. I know a handful of engineering people who work in quantum computing, a bunch of people who work as undergraduate physics who moved into more of a hands-on or something like that. Maybe not hands-on, but as a different scenario of quantum computing than what a PhD is required for. Ideally, it would be nice if eventually people can just get masters and work on quantum computing, and that a PhD for quantum computing won't really necessarily be necessary. Julie, you streamed for 10 hours today. Oh, well, thank you so much for the raid. It was definitely good to see you. Thank you for the kind words. Take care, Julie. Take care. Thank you so much. All right. What's next? So yeah, I don't think it's necessary to have a PhD. I think a master's eventually will be more than enough. Sever says, are you aware of Shor's algorithm and its impact on encryption? I am not. I know that's big in quantum computing. I have not familiarized myself with it. There is significant amounts of people who do know it. And you should ask in Discord, because there are people who know more about it. It's actually come up recently in Discord. It is one of the things on my to-do list to learn. But I haven't got there yet. Strawberry says, what's the quantum computer way to provide feedback loop? There is no loops in quantum computing. That is something we talked about on Friday. Yeah, loops are not allowed in quantum computing. I think they go into detail later on in the book, but they do say very explicitly, and we talked about it on Wednesday, or on Friday. I said I don't know why some of this is true, but I think it's really important to say it. And yeah, they say right here, there are a few features allowed in classical circuits that are not usually present in quantum circuits. First of all, we don't allow loops. That is feedback from one part of the quantum circuit to another. The circuit is acyclic. So, Nielsen and Chang. I don't know what it means. I imagine you have to set up a series of gates that are very similar and are just honing in on parameters. That would be my guess. Yes, that's the book I showed you before. Ah, there's Admiral with the Shor's algorithm. Shor's algorithm is important to understand because it helps one understand quantum Fourier transform. It will be learned. It will be learned. Yeah, you have to unroll the loop. Sakuza said, does teleportation in terms of quantum states, I guess it's magic, mean teleporting real things or some kind of, how do we understand teleporting? So that black box of information that you can manipulate, yeah, you don't know all of the information of that system, right? But you can teleport that from one computer to another computer without actually doing any, like, moving. Like, you don't need to put it on a hard drive and take it to another computer. There's actually a way of doing it mathematically where you can take that algorithm, move from one computer to the other computer by moving classical things from one to the other. But you have to prepare it. Yes, you do have to prepare it. Yes. Francisco, thank you for the follow. Welcome to the channel. So it knows where to go. Yep. And you do have to send it you have to send information classically, but you can preserve the quantum information without looking at it, without measuring it or anything. But it is instant from one place to another? No. So you do have to send the information classically, so you don't break the information paradox. Like you cannot send the information faster than the speed of light. You have to send a classical piece of information in order to recover the state at a different location. Yeah, no light speed. Unless you're using photons. You're very good at manipulating those photons. But then it's only light speed. No faster than light travel of information. You still have to move some classical information. So for e.g., you're working through 3 parameters. Outcome depends on linear, so like 1A. How do you estimate weights of each parameter in quantum computing without a feedback loop? Many iterations. Many iterations. So you have to send like thousands of iterations. Can you do that? I think, isn't that what China was trying to do with their quantum teleportation thing? I'm not sure. It's a thought experiment presented in the book. But I know that China has been working on quantum information and communication with a satellite. I don't know if it's the same thing, but it's something to Google. And maybe you might get a hit. You know, I'm not saying that China did it. I'm saying that I've heard of China working on something similar. I would Google it to double check. But what do iterations do without feedback loop? No learning. Right. No, it's about just hitting parameters right. So you set up a parameters a certain way. Like you still have to prepare it. And then you just set up parameters and it kind of like, it's like, I always pictured it as a funnel. I'm really not the best person to ask Strawberry. I'm not 100% sure. I can't ask my advisor again because he does know about it. And he walked me through it one time, and I'm trying to remember how he said it. But it's basically like you take your bits and you just spread them as wide as possible over the phase space. And then you just send them through a funnel of parameters to try to get it to work a certain way. But again, I don't know about the learning aspect of it. Yeah, let me ask my advisor. Or I'll ask one of my group mates, because my group mates study machine learning. So classical information means we really send stuff from antenna to antenna, yeah. Yep. Sending radio waves, light waves, whichever one. So is it more like we try every solution and filter out the solutions that actually work? Yeah. That's how I would do it. So you send out, you just spread it all out, and you funnel it into a series of parameters. And maybe it's not the best for like learning, but I don't know. John says, can you tell us what field your big idea belongs to? It's what I study. It's the overlap between quantum field theory and quantum computing. That's what my ideas are. And when I just say big idea, I don't mean like, you know, revolutionary and like that. I just mean like really broad. It's a really big idea that covers a lot of ground. And the revolutionary aspect of it is not something for the researcher to determine. That's something for the field to determine. Maybe I should have emphasized that earlier. But I just mean like broad and like it covers a lot of ground quickly. You're wondering from a software engineer perspective. Okay, I'll definitely include that. So do we always need to channel even with all the crazy theory stuff you think up? Yeah, because ultimately the only information you're going to get out of a quantum computing is classical information that you do at a measurement gate. So ultimately you always need to channel things through a quantum computer. That's why I'm so interested with time. Because in a classical computer, time makes perfect sense. Right? You just send it through bits of information. Every time you want to adjust a bit of information, it's just one time step after another. But in quantum information, you just can't know that black box of information, so there's no idea to know actually what goes on inside of it. What takes time in a quantum computer? In a classical computer, CPU, clocks, and memories. Now you're getting it. Ain't that the $1 million question? Bachman has hit the nail on the head with that question. That's why I study it. That is why I study it. In theory, what we do is we take the configuration space. So you have some particles, some states in, some states out. How many different ways can you get some states in, some states out? It's called the configuration space. You put that configuration space on a lattice, and you have a finite amount of paths through that lattice. Okay? And then the time steps really occur with how many times you can do that before your state decoheres into its ground state or until you lose the information. So you want to try to get the information extracted out of the end before that decoherence, right? So like you can send your state through a bunch of different gates, and like they're big gates. But like the time step in this is you take one of the parameters of the lattice, namely like you pick a dimension of lattice. So if your lattice exists like, you know, dot 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 dot. So if your lattice exists like this way, then each dot, I know you guys can't see it, I'm sorry. It just doesn't show up. But if you take a dot, just picture a two-dimensional lattice here. So you can picture like this as your time dimension, but you don't really take apart the time dimension. You just sort of let it be a lattice spatial dimension. You wick rotate out of time into like a spatial dimension. And then you just do on configuration space, you just count up the paths, basically. But yeah. Lattice plus ladder equals lattice. So the decoherence is a problem. The target is not stable. Yeah, like if you wanted to entangle states, you could entangle as many as you wanted, like right off the bat. But like eventually you're going to interact with the environment, and you'll decohere and just lose energy and go right to the ground state. And whatever particle you're using for the quantum computing is just going to fall into its ground state at some point. Okay, last question, then I got to get going. You guys, I am blown away. So if you guys don't know, I am in a funk. I'm a physicist in a funk. I had a really good idea, and now I'm working on it, and it's really difficult. And everybody who works on physics knows this. Sometimes ideas are really, really complicated and require a lot of thought, and it can be very disappointing, I guess. If like you're struggling, it can be you could be disappointed with how much progress you made. You can be disappointed with the prospect of having to do years worth of work to understand a question that you have right now. There's a lot of problems that go into it. So, yeah. So anyways, I've been in a bit of a funk. So I was not doing a building today. So I was just doing question and answer, and I am floored with the amount of questions, and the level of questions has been fantastic. So let me just answer. I guess I'll answer these last two, and that'll be it. We'll cut it off now. So Goofy Lagrangian says, do you think the starting line for grad students is moving further and further, making it harder for physics, maths PhD to actually start making actual significant research contributions eventually after starting in graduate school? I don't know, but if it does, I think it moves with the field. So what I mean by that is to not be discouraged by it. I think that the peak, and I just talked about this on my latest YouTube video, which this is a VOD from Friday's stream, is that like the goal used to be like, oh, like you have like all of your biggest work gets done right at the beginning. That's where if you've gotten past like 25, then you're useless, you know? And like I don't see that as true. I think that you have more freedom when you're younger. So it allows you to challenge more stuff when you're younger. But I still think that the age gets of like the average age of like your biggest idea or your biggest breakthroughs or your most, you know, radical changes is moving later and later. And I think that we as graduate students should be okay with that, and not worry too much about our age as we progress. I think in general, physics. And I said this before the rates, I'll say it one more time. I've said this many times, so I'm sorry if it's getting repetitive. But the best tool a physicist has is the next generation of physicists. So us as physicists should be focusing on teaching and mentoring and learning, as well as research, obviously, because you want to research yourself. You can't move physics forward if you don't research. That should be the goal. But like not having a big breakthrough at an early age, I wouldn't worry too much about it. I'm focused on teaching. That's why I do this. That's why I try to share any information I have, and I'm honest about when I don't know something. Sukaza, thank you so much for the follow. And if I do make a mistake, I always want people to tell me. SH3G5, thank you for the follow. Welcome. But I do think that age is getting pushed back farther, just as a general statistic. But I also would emphasize it less than others would. Also, Poster, thank you so much for the follow. Welcome to everybody. And then Entia, last question. Do you know much about spontaneous parametric down conversion? Okay, I don't know that. I don't know that at all. So what exactly happens in nonlinear crystal? Yeah. Entia, if you are interested in that, I can send you to my Discord. There are people who focus on condensed matter physics in the Discord. It's a very much a solid state question, and I don't know. Sorry. I'm much more into the particle and quantum stuff. Quantum mechanics is kind of like the thing, but not quantum mechanics in materials. That's a big, hard, like I don't know most of those questions. So I'm sorry about that. So Helfer, I'll just answer these last two. Commentator, nice. Who is, when is, what is? PhysicsOH. And then Helfer says, why do the brown papers enveloping pastries turn transparent? Fats. It's the fatty acid. It removes the color pigment. I don't know where it goes, though. I just know that the fats and oils remove the color pigment, which you probably already knew that, so I don't know who I'm talking to. I don't know, I don't know if you're getting any information from it or not, but oils and fats remove color pigment. I imagine it just rubs off. Imagine the color pigment is loosened from the material and rubbed off on whatever touches it. But so like when you're cooking, because I cook professionally. So if you are new to the stream, I was a former chef. I worked in New York City for a long time. I worked at eclectic restaurants, gastro pubs. I worked all over the place. And it's quantum magic. Is it real? Yes. And it's certainly, yeah. And when you're cooking, fatty stuff is like a very bad mouthfeel, and you always want to like get rid of it. So you put it on papers and stuff. And it was always funny because, well, it's not funny. It's kind of gross because everything turns transparent sometimes. I don't even know why I'm talking about that. I'm tired. Anyways, how did I transition from cook to physics? It was a long transition. I had a bit of a, here's my whole story. If anybody would like to full read, this is my full story. It's very personal. A lot of like, about my kind of like struggle. But yeah, it's a blog post about the struggle from going from cooking to physics, but I basically had like a fallout where I realized my life was spiraling. I was struggling to be a role model for my kids and a good husband. As far as like, my wife says I was a good husband, and I felt like bad because I felt like I was emotionally not there. It was rough. We'll just say it was rough. But she always says that I was still a good husband and a good father, but I didn't feel like it, and I felt like if I continued on cooking, I would give my kids the message that they can continue doing something that they're unhappy because that's where they're at. And I was very unhappy, and it was hard to hide anymore. So I eventually, one day, it all came to a head in a very explosive, I was by myself, but in a very explosive way in the pantry room, which made a very large mess that I had to clean up. It's just one thing that someone said to me just set me off, and I went and destroyed a bunch of stuff, is the short and short of it. And I realized that my life was just, I was going to become someone I was very unhappy with if I wasn't already there. So I decided I need to make a change. And it was very gradual, but eventually it changed. So yeah, it was definitely a very interesting experience, and I learned a lot from it. But anyways, who should we raid? Does anyone have any ideas on who we should raid? And as far as why I just didn't like grab a job and like, just get out of physics, is because I really wanted to show my kids that they could do stuff that they wanted to if they were willing to work hard enough for it and make sacrifices and struggle and, get up at 5 and go to bed at midnight, days and days and days just to get your homework done, your grading done. I had to work full time. Ask your quantum people about anions. Okay, will do. CSP and Lantern are on. I don't know if I know. Oh, Cogpsych Prov, yes. And who's Lantern? Ty is on. Lana's on. We rated Lana relatively recently. We rated Cogpsych Prov even more recently. Storm Chaser is on. Where are we gonna go? Is making soap. Why don't we go to Ty? It's been a while. Oh, Freckled Science is on too. Freckled Science. Where should we go? Freckled Science or Ty? What is Cog doing? Is he answering questions? We have been to him very recently, though. I like to spread it out. We've been to Freckled very recently, too. Let's go to Cog Psych Prof. Let's go say hi to Cog Psych Prof. He's a cognitive psychologist. Ask him your questions about psychology. He's just a really good guy. Thank you so much for today, guys. I honestly can't thank you enough for today. You guys have been absolutely fantastic, and I appreciate everybody asking me fantastic questions, being involved, being helpful, reaching out to me. Several people reached out to me on Discord and just double-checked if I was okay. And like that means a lot to me, to know that like all I had to say was, hey, I'm in a funk, I'm feeling a bit down on myself. And like all these people just reach out to me. It means a lot. So thank you very much for that. You're wonderful people. I will see you Wednesday. Electricity and Magnetism with Griffiths, our good friend. As well as another, pay attention to the socials because we're going to do another Old Man Reads Old Books on Wednesday. And if you guess the book when I start playing the game, then I'll put your name in the title. Or anything else you want to be put in the title. So again, follow me on the socials. Here we go, socials. If I missed it, Health4 and Seo, thank you for following. And welcome to the channel. I guess I'll see you guys on Wednesday. Take care, everybody. Bon voyage! I should go there, shouldn't I? Probably. If you're still here, you can watch me dance for a little bit. All right, shutting down.